In this lecture, I want to give you some tips and tricks for the next set of challenges. I won't lie to you. These challenges are going to be tougher than the previous challenges. There's one big reason for that. In order to solve these exercises, you're going to have to use functions we haven't gone over. I know that seems unfair, but I did it for a specific reason. There isn't a course or book on this planet that can go over every function or solution. You're going to have to take the time to look up solutions online to solve specific problems. With that being said, most of these challenges can be solved with a few lines of code and a bit of research. Hopefully, you paid attention to the lectures where I talked about reading PHP's documentation. Those skills are going to come in handy. However, I know that not everyone feels confident with their skills. Don't worry, I decided to add hints to these exercises. If you don't want to be spoiled, I recommend heading on to the next challenge. For the rest of you, let's go over what you can expect to find in the hints. On Udemy, the hints can be found on the left sidebar under a section called Hints. If you're watching this on YouTube, the gist that contains the exercise has a section with a similar name that you can check out. Currently, I'm viewing the next exercise, which is the robot name exercise. The overall goal of this exercise is to write a function that generates a robot name with a specific format. I'll let you read the description when you get to it. Under the Hints section, I provide a list of steps and functions that you can use to tackle this challenge. Keep in mind, there's more than one way to solve a problem. If you end up using a different solution, that's fine. The steps outlined in the exercise are what I would do. So, be sure to check out the documentation for each of these functions and learn how they work. You can expect similar hints for the other exercises. However, the last exercise has a bit of a curveball. Let's take a look at the series exercise. If we click on the Hints section, one of the hints I provide is an instruction to search for a function. Rather than giving you the function's name, I provide a search query you can use to search for that function. Realistically, you're not going to be able to remember every function name. Learning how to search for functions is an invaluable skill you can pick up. When you get to this exercise, I want you to search for a function with this phrase. The function that pops up in the results will be useful. It'll be up to you to look through the results to learn what the function is. One of the most important things worth highlighting about this search query is the word PHP. PHP is not exactly a unique programming language. A lot of its features can be found across multiple programming languages. If you were to search online how to count the number of characters in a string, you might get results related to another programming language. I always recommend including the name of the programming language whenever searching for a solution. Alright, that's all I have to say. If you have trouble with the exercises, don't worry. They're meant to be challenging. I'll be sure to walk through each exercise with my solution. All I want you to do is try your best. When you're ready, I'll see you in the next lecture. Good luck. In this lecture, let's review the solution for the robot name exercise. According to the description, our job is to generate a name for robots in a factory. Their names must follow a specific format. The first two characters of the name must be uppercase letters followed by a 3-digit number. The most important step is to generate completely random names each time the function is called. Let's look at the Hints section. I've outlined the steps you should take to complete the exercise. First things first, we must generate an array of valid letters. Before generating a random letter, we must have a list of possible letters to randomize. One solution is to create an array with each letter. In the code, we have a single function called getNewName. Inside the function, define a variable called letters with an initial value of an array. In this array, we can start adding individual letters like so. This is a completely valid solution. If you created an array like this, that's great. However, the one thing I don't like about this approach is manually inputting the letters. It also looks cluttered. In the future, we may want to include lowercase letters. Rather than manually writing each letter in an array, we can use a function called range. In the Hints section, I've provided a link to this function. Let's check it out. According to the description, this function can generate an array containing a range of values. The range of values can be configured through the parameters. Let's scroll to the examples section of the documentation page. I find that by looking at the examples, it's possible that a solution is already available for what I want to do. Looking closely, the third example has something similar to what we're trying to do. The range function generates an array of letters ranging from A to I. It's not uncommon to tweak examples specific to your needs. In this case, this example can be adjusted to uppercase letters and extend the range from A to Z. Let's give it a try. Back in our editors, replace the array assigned to the letters variable with the range function. This function accepts the starting and ending range. Let's pass in A and Z. Just like that, we have an array of letters. The next step is to randomize the letters. Currently, the range function produces an array in alphabetical order. Before we can grab a random letter, the value should be moved around in a random order. Luckily, there's a function for performing this exact action. In the list of functions, click on the shuffle function. The shuffle function performs shuffling, which is another way of saying randomizing the values in an array. If we look at the function definition, there's one piece of information worth noticing. The array parameter is passed in by reference. If we pass in the letters array, our array will be automatically updated. We don't need to reassign the value. Let's try using this function. Back in our script, call the shuffle function with the letters array. We're almost finished. According to the outline, the next step is to generate a random number containing 3 digits. Unlike before, we don't need an array of possible numbers. PHP has a function for generating random numbers called mtrandom. After the shuffle function, create a variable called number with the following value, mtrandom 100,999. The mtrandom function accepts 2 numbers, which are the minimum and maximum threshold. Once we've got the random number, the last step is to return our results. I'm going to be using string interpolation, but string concatenation works just as well. Let's return the following: letters 0, letters 1, number. In this example, we're grabbing the first 2 letters from the array. Lastly, we're adding the number. That's it. Let's try running the tests to see if our function passes. After a few moments, the test passed. Great! We've got a function for generating a random name for a robot. If you would like, you can try improving the current implementation. For example, you can try adding support for lowercase letters. Alternatively, you can allow duplicate letters to appear in the name. Lastly, you can prevent the function from generating the same name twice. It's unnecessary to do these things, but it can be a good way to challenge yourself. In the next lecture, let's jump into another exercise. In this lecture, let's work on solving the Armstrong numbers challenge. An Armstrong number is a number that is the sum of its digits, each raised to the power of the number of digits. In the description, I give a few examples as well as a link to more information. The code snippet contains a single function with one parameter, which is the number to check if it's an Armstrong number. Our function must return a Boolean. If the number is an Armstrong number, the function should return true, otherwise false. To accomplish this task, we must begin by splitting the given number passed into an array. In the array, each number should be inserted as an individual item. Therefore, we must convert the integer into an array. For this portion of the exercise, we can use a function called string_split. In the function, create a variable called digits with the value set to string_split. This function takes in a string and splits the string by each character into an array. Let's pass in the number parameter. There's just one problem with our line of code. Let's look at the documentation for the string_split function. In the documentation, the string parameter is annotated with the string data type. However, we're passing along an integer. Typically, PHP would perform type juggling, but that's not going to work in our script. back in the editor, strict typing is enabled. PHP is going to throw an error at us for passing in an integer when the function expects a string. To get around this dilemma, let's typecast the number parameter into a string like so. As we know, integers are casted into strings as is. PHP simply wraps the value with quotes. The original number does not get lost, so it shouldn't be a problem to typecast the parameter into a string. This is important to keep in mind. If you're going to be using PHP's function while enabling strict typing, it's always worthwhile to check the parameter's data types to avoid errors. It's time to start looping through the array. We must perform exponentiation on each of the digits with the number of digits in the array. At the same time, we must store an array of results. I think this is the perfect opportunity to use the array map function. Set the digits variable to the array map function. Next, pass in an anonymous function. Technically, we could use an arrow function to solve this exercise. However, Udemy doesn't support arrow functions, so if you tried to use an arrow function and encountered errors, that's why. The callback function will be called on each iteration of the loop. We can accept the value from the current iteration as an argument to our anonymous function. Let's refer to it as digits. Next, we need to calculate the exponentiation. Return the following: digit, exponent, count digits. This solution works, but can be improved. Let's take a moment to think about this solution. Every time PHP loops through our array, it's going to perform this expression. Before a value can be exponentiated, PHP must wait for the count function to return a value. If we consider it, the count function always returns the same value. After all, the digits array doesn't change. It would be better if we outsource the value returned by the count function into a variable outside of our array map function. Let's give that a try. Below the digits variable, define another variable called digit count. Its value will be the count function from the array map function. Next, let's use our digit count variable in the return statement. Lastly, we must add the use keyword to access variables defined outside our anonymous function. Inside the parentheses, add the digit count variable. The results will be the same, but this solution is much more efficient. With a simple adjustment, our anonymous function doesn't have to wait for the count function to finish running. It's a small optimization, but an optimization nevertheless. Afterward, let's pass in the digits array to the array map function as the second argument. There's one last step. We must verify the sum of the digits is equal to the number passed into the function. At the end of our function, return the following: array sum digits equals number. The array sum function loops through an array, calculating the sum of all the numbers. Now, hold on a moment. Isn't our array an array of strings? Initially, yes, because of the string split function. However, in the array map function, we're using the exponentiation operator, which produces an integer. Therefore, all numbers are converted back into integers. Just like that, we've got a working function. Let's try running the script. Udemy has passed our function. Awesome! We've successfully created a function for checking an Armstrong number. If your solution looks like mine, that's great. If you did something else, that's also fine. As long as you got something working, that's what matters. In the next lecture, let's tackle one more exercise before learning more PHP. In this lecture, we're going to walk through the final challenge of this section. The goal of our function is to create an array of numbers based on a single number. In the description, I've provided an example. Let's imagine we have the number 49142. I may want to grab portions of the number. Let's say I wanted numbers in groups of 3. 491 would be the first group. 914 would be the second group. Lastly, 142 would be the last group. I'm simply grabbing the first 3 numbers. Next, I'm moving over 1 to grab the next 3 numbers. I continue to do so until I reach the end. If I wanted to grab numbers in groups of 4, the same group of numbers would give me 2 numbers. Our function has 2 parameters, which is the initial number and the size of each group. Let's get started. Click on the Hints section from the exercise. As always, I've provided instructions for writing a solution. Unlike before, I decided not to include every function that you'll need. Instead, I've provided a search term to help you search for a function you'll need. We'll talk about it in a moment. In our function, the first step is to validate the data passed into the function. As noted in the description, if the size is larger than the number itself, we should return an empty array since we can't produce results when the size is too big. Vice versa, if the size is less than 1, we'll also return an empty array. Before we can check the size, we must grab the length of the number. In the hints, you must search for how to get the number of characters in a string in PHP. Here's what you should be presented with. You may get different search results based on when and which search engine you're using. All the search results are unanimous. We must use a function called string length. Feel free to read each page listed in this search. Most importantly, you should check out the documentation page for the functions recommended by the search results. Let's give the string length function a try. Back in the editor, add a conditional statement. The condition will be the following: size greater than string length series, or size less than 1. There are 2 conditions. The first condition we've written checks if the size parameter exceeds the number of characters in the series parameter. The other condition checks if the size parameter is less than 1. If either condition evaluates to true, let's proceed to return an empty array. Otherwise, we can proceed with grabbing groups of numbers from the original number. Below the conditional statement, create a variable called results with an initial value of an empty array. This array will be responsible for storing the results. The next step is to start populating the results by looping through the number. The question is, which loop should we use? Well, since we don't have an array of values to loop through, I think we should use a loop that runs based on a condition. Add a for loop. First, let's initialize a variable called I with an initial value of 0. Next, write the following condition: I less than equals string length series minus size. The condition we've written checks if the I variable is less than or equal to the length of the series parameter minus the size parameter. We're going to use the I variable to help us set the starting position of where to grab a number from the string. As long as the I variable is smaller than the expression on the right, there's room for grabbing numbers. Once we exceed this point, there aren't enough numbers left to grab. Lastly, let's increment the I variable. Our next step is to start adding a group of numbers to the results array. A portion of a string is known as a substring. This concept is not specific to PHP, but can be found in most programming languages. PHP has a function for grabbing portions of a string called substring. Let's add a new item to the array by adding a pair of empty square brackets. Set the value to the substring function. This function has 3 arguments. The first argument is the original string. In our case, this would be the series string. Next, we must pass in a starting position. Where should PHP start grabbing the string? Keep in mind, the first character has an index of 0. The second character has an index of 1. We always want to start from the beginning when the loop runs for the first time. During the second iteration, it should start from the second character, so on and so forth. It just so happens that we have a variable that slowly increments, which is the I variable. Let's pass that in. Lastly, we must provide how many characters to grab from the starting position. This information is available via the size parameter. That should do it. The last thing to do is to return the results array. Before testing our code, there's one more thing we should do. You may have noticed it already, but we're calling the string length function twice. Actually, we're calling it from multiple times from our loop. If you were screaming at me from behind your screen, don't worry, I wasn't going to let this mistake slide. This is a good opportunity to point out that your code may not always be optimized the first time around. When you're trying to solve a problem, it's important to just solve the problem. If, along the way, you write unoptimized code, that's perfectly fine. The most important thing is to revisit your solutions before shipping code to production. This is more common than you think. If you optimize too early, you may find yourself disappointed because the solution you thought of isn't suitable for the problem you're trying to tackle. As a result, you've wasted time optimizing code that wouldn't have worked to begin with. Above the conditional statements, define a variable called series length. Its value will be the string length function with the series variable. Next, update our conditions to use this variable instead of calling the string length function directly. There's another optimization that we made without realizing it. It's not optimized for performance, but for readability. Technically, we could wrap this portion of the code with an else block. It's completely valid to do so. However, it's considered good practice to avoid adding an else block if you don't need to. In our case, we don't need an else block since our code produces the same results. By not using an else block, we don't have to indent our code, which can improve readability. Let's try running our script through the test. As you can see, our code works. Awesome! We've successfully completed the exercise. Hopefully, these exercises helped improve your problem-solving skills. In the next section, let's get back to learning PHP. In this section of the course, we're going to get into Object-Oriented Programming, or OOP for short. Object-oriented programming can be a difficult topic to comprehend. It takes everything we've learned so far to another level. So, what is OOP, and why should we learn it? To kick this discussion off, we should discuss the idea of a programming paradigm. It's a big word, but it's just fancy talk to describe a programming style. Programming has been around for decades. Developers have developed styles for how applications should be written over the years. Programming paradigms provide a clear and concise way for how applications can be organized. You can think of them as guidelines for writing a program. Paradigms apply to programming in general. They're not specific to PHP. With that being said, there are 5 popular paradigms you'll come across. They're imperative programming, procedural programming, functional programming, declarative programming, and last but not least, object-oriented programming. For the sake of brevity, we're going to focus on 3 of these paradigms, which are procedural programming, functional programming, and object-oriented programming. Let's start with procedural programming. Believe it or not, we've been following procedural programming for a while now. The idea of procedural programming is to subdivide a program into functions. For example, let's say we were baking a cake. We can divide each step of the process into functions. After defining those functions, we can invoke each function in the order we'd like to perform those steps. The idea of procedural programming is to treat our program as a series of steps. Code is executed from top to bottom. Initially, procedural programming might seem like a great paradigm to follow. However, the biggest flaw with this approach is reusability. Typically, procedural programming leads to duplicating the same functions over and over again. That's something we should avoid to boost productivity. Let's step away from programming paradigms to talk about a concept known as the separation of concerns. This principle is not specific to PHP. We can apply it to any programming language or framework. In fact, we can apply this principle to the real world. Hospitals can employ hundreds of people. There are surgeons, nurses, techs, chefs, janitors, etc. Each person is given a specialized job. Not a single employee performs all jobs. You can apply this concept to almost any industry. Businesses always assign specific responsibilities to each employee. This principle can be applied to programming. The separation of concerns principle states that we should split our logic by responsibility. This principle keeps our code base clean and organized. Object-oriented programming is a style of programming for implementing separation of concerns. I know you can't understand what's going on in the code snippet from this slide. However, the main point I'm trying to convey is that object-oriented programming allows us to split our code by responsibility by using something called objects. An object is a generic term to describe code grouped by responsibility or feature. It's code that shares a relationship with each other. I know that doesn't make much sense. Don't worry. In the next lecture, we're going to start creating objects. The most important thing to understand is object-oriented programming is a style of programming that emphasizes breaking our application into objects. By using objects, we can easily reuse code along with other great features found in object-oriented programming. This entire section is going to be dedicated to object-oriented programming. As we go along, you'll slowly understand why it's a popular programming paradigm. There's one more paradigm I should briefly mention called functional programming. It's similar to procedural programming, with one exception. Functional programming focuses on using functions to build an application. However, functions must be treated as first-class citizens. This is another way of saying that functions can be assigned to variables, passed as arguments, or be returned by other functions. It basically takes functions to the next level. In recent years, functional programming has become more popular thanks to languages like JavaScript. However, for PHP developers, most developers prefer object-oriented programming, so that's what we're going to focus on. In the next lecture, let's get started by writing a class. In this lecture, we're going to create a class. Before we do, we must answer one crucial question. What is a class? A class is a set of instructions for creating an object. You can think of it as a blueprint for building a house. A blueprint contains instructions on how a house is built by providing details on the layout and dimensions. You can't live in a blueprint. It's just a piece of paper with information on building a house. Interestingly, we can build multiple houses based on a single blueprint. But what exactly is an object? Well, if classes are blueprints, then objects would be the physical houses themselves. In the programming world, objects can be anything we want. We can use an object to represent a button on a page, or a user on our site. We have complete control over what an object represents and how it works. Before creating an object, we must define a class. In our project, let's create a new file for containing our class. Create a file called account.php. Inside this file, let's add a keyword called class. As you might suspect, this keyword allows us to create a class. Following this keyword, we must provide a name for our class. Similar to functions, class names must be unique. Let's set the name to account. Lastly, add a pair of curly brackets. There are a few things worth mentioning before moving further. Firstly, the name of the class matches the name of the file. This step is not required. We can freely use any name we wish. However, it's common practice for a class to have the same name as the file for consistency. But why? Most developers agree that a single class should occupy a file, one file per class. Technically, we could add additional logic or define another class. It's not against the rules, but keeps our project maintainable if we know where to find specific portions of code. Secondly, the name of the class uses Pascal casing. Previously, variable and function names were camel-cased. On the other hand, classes are Pascal-cased to help developers identify a class from a function. You don't have to follow these naming conventions, but it's what most developers follow and what you're likely to encounter when opening new projects. Moving along, we have a pair of curly brackets to act as the body of the class. Anything written inside the class belongs to it. For now, we're going to leave the class empty. Our class is ready to be instantiated. One word you're going to come across is instantiate, which describes the process of creating an object from a class. Oftentimes, you may hear developers refer to an object as an instance. The words object and instance are interchangeable terms. However, there is a difference. The copies generated by a class are considered to be objects, whereas a specific copy of a class is considered to be an instance. But, once again, they can be interchangeable terms from time to time. Let's open the index.php file. I'm going to clear the contents of the file for the purposes of this lecture. Next, let's load the account.php file by using the require once keyword. Since the class definition exists in a different file, we must load the file before creating an instance. After the file has been loaded, we can proceed with the instantiation. Define a variable called myAccount, set to the following value, new account. I'm introducing a new keyword called new. This keyword allows us to create a new instance of a class. The class name can be specified after the keyword. Most importantly, the keyword returns the instance, which can be stored in a variable. After storing the instance, we can reference that instance through the variable. Let's give that a try. Below the variable, call the variable dump function with the myAccount variable. In the preview, the variable dump function outputs the contents of the object. Since we didn't include anything in our class, the object is empty. Take notice of the data type. PHP assigns the object data type to instances of our class. This data type gets applied regardless of what class we're using. So, that's how we can create a class. Nothing fantastical, but it's a start. There's one more thing I want to mention before moving on. We're not limited to a single instance of a class. Multiple instances can exist within an application. For example, let's create a variable called John's account, set to a new instance of the account class. We're going to dump the contents of the John's account variable with the variable dump function. In the preview, we're given two copies of the account class. They look similar, but PHP recognizes them as two completely different instances. But why would we want two instances of the same class? Well, classes can contain data, which is unique to each instance. If our account class had data, these instances would have unique copies of that data. Changing data in one instance does not affect the other. This is what makes object-oriented programming powerful. We're able to reuse classes without worrying about affecting other instances of that class. In the next lecture, let's start adding data to our classes to showcase this feature. In this lecture, we're going to start adding data to our classes. Data inside a class is referred to as properties. They're dead simple to add. Let's continue working on the account class from the previous lecture. Inside the class, add the following with me. Public name. Two things worth examining. Firstly, properties are really just variables in a class. If we define a variable outside of a class, it's treated as a regular variable. On the other hand, variables defined inside a class are referred to as properties. It's all semantics. Secondly, I'm introducing a new keyword called public. Properties must have something called an access modifier. An access modifier refers to how accessible a variable is from a class. As we know, defining variables outside of a class makes them accessible everywhere. Our variables can be updated from functions or from different files. We don't really have control over where the variable can be updated. That can be problematic. Variables can easily have their values overridden. For this reason, properties, which are variables defined in a class, can limit access as to where a property can be updated. In the resource section of this lecture, I provide a link to the documentation page for access modifiers. We're going to dive deeper into each access modifier. For now, I want to focus on a single access modifier, which is public. If you're interested in more information, check out this documentation page. Head back to our editors. The public keyword instructs PHP that the property can be accessed and updated from anywhere. It's similar to defining a regular global variable. Access modifiers must always be added to our properties. let's add another property called balance. Unless I state otherwise, you should always assume that a property should be public. After adding those properties, we can refresh the page to view the result. This time, both instances have the properties from our class. Since both properties don't have a value, PHP defaults to null. However, PHP uses a different default value when our properties have data types. At the top of the file, let's enable strict typing with the declare statement. Just in case, let's add the same statement to the index.php file. Great. Back in the account file, let's add data types to our properties. Data type must be added after the access modifier. Let's set the name to string and balance to float. After making those changes, the default values have been set to uninitialized. The uninitialized data type is a special type for properties. If we think about it, our properties cannot be set to null since the data type has been explicitly set. For this reason, PHP sets the value to uninitialized to inform us of a property without a value. With that being said, we are allowed to set a default value. For example, let's set the balance property to 5.5. We're not limited to using simple values. Simple expressions can be used as the value. Instead of using a floating number, let's add 5 plus 5. As you can see, the expression works. However, there are limitations. PHP does not allow us to call functions. For example, let's set the value to a function called integer value with a value of 5.5. The integer value function is defined by PHP for converting a data type into an integer. It's the same as typecasting with the int data type. Typically, this line of code would work for regular variables. However, if we look at the preview, PHP throws an error. Functions cannot be used from within the property definitions. I'll revert the value to a simple number. So, we have a property. The question is, how can we access the value? Let's head back to the index file. In the first variable dump function, add the following after the myAccount variable: minus greater than balance. In the preview, the property gets rendered. We can access a property from within an instance by using an arrow followed by the name of the property. Since our property is public, it's perfectly acceptable to read or update the value. In addition, the property can be referenced without the $sign character at the beginning of the name. It only needs to be included with the reference to the instance. Before logging the value, let's set the balance property on the myAccount instance to a different value. As you can see, our property gets updated. More importantly, take a look at the second object. We only updated the first instance. The second instance retains its original value. This is important to understand. Instances contain unique copies of their data. If we change data in one instance, other instances of the same class remain unaffected. This behavior is the beauty of object-oriented programming. In the next lecture, let's learn of an alternative solution for modifying the default values of a class. In this lecture, we're going to learn about methods. A method is a function defined inside a class. Similar to how variables defined in a class are referred to as properties, functions defined from within a class get referred to as a method. Custom methods are going to be a topic explored in another lecture. For this lecture, I want to focus on magic methods. In the resource section of this lecture, I provide a link to a list of magic methods. A magic method is a function automatically called by PHP. Typically, we're responsible for calling functions after defining them. PHP never executes a method by itself. However, magic methods are different. PHP is capable of calling a function from within our class during specific events. For example, let's explore a magic method called construct. Head over to your editor. In the account class, let's define a function from inside the class. The name of the function must be called the following: ___ construct. All magic methods start with 2 underscore characters. For this reason, PHP recommends avoiding naming your methods and functions with 2 underscore characters to reduce confusion. After defining the function, add the public keyword. Similar to properties, we can restrict the access of methods with access modifiers. Going forward, we're always going to set our methods to public whenever we define them. So, why did we define the construct method? Well, it turns out that PHP calls this method whenever a class is instantiated. This event gives us the opportunity to set up our class before other methods are called. Interestingly, like any other function, we can add parameters. Let's add 2 parameters called newName and newBalance. Their data types will be string and float, respectively. We're going to use these parameters to update our properties. Inside the function, set the thisName property to newName. Out of nowhere, I've introduced a new keyword called this. You heard that right. The this variable is actually not a variable, but a keyword. As we know, instances contain unique copies of the properties from a class. Since multiple classes can have the same properties, how does PHP know which property to update from which class? This problem compounds even further when we account for global variables. To avoid updating incorrect properties, we can refer to the current instance via the this keyword. The this keyword represents the current instance. As a result, we can access properties like we would any other method. In this example, we're updating the name property. Let's do the same for the balance property by setting it to the newBalance parameter. Next, let's remove the default value for the balance property from the top of the class. There isn't a point in setting a value for this property if we're going to update it when the class is instantiated. After making those changes, we're going to receive an error from PHP. It's stating that we're providing too few arguments to the construct method. As I mentioned before, PHP automatically calls the magic method for you. It's calling the construct method when the instance is created. Whenever receiving the argument count error, the error indicates a function is being called with missing arguments. Despite PHP being the one calling the construct method, it's our job to supply arguments to this method. Let's go back to the index file. So, how do we pass on data while the instance is being created? It's simple. We can add parentheses after the name of the class like so. The parentheses are optional if your construct function doesn't have parameters. For the rest of this course, I'm always going to add the parentheses during instantiation, especially if the construct method doesn't have parameters. It's my personal preference. PHP is not the only language I use. While parentheses are optional in PHP, they're not optional in other languages. Therefore, to be consistent, I'm used to adding them when there isn't data to pass on. Alright, let's pass on data. From my account instance, I'll pass in a random name and number. While we're here, let's remove the second instance, variable dump function, and update for the balance property for the myAccount variable. In the preview, both the name and balance was updated with the values passed into the construct function. By using the construct function, we're able to change the default values of our properties during instantiation. This feature allows us to configure our classes to our specific needs. The construct method is probably the most popular magic method. You're going to be using it frequently. As for the other magic methods, we're not going to be diving too deep into them for this lecture. I'll introduce additional magic methods as we need them. For now, knowledge of this method will suffice. In the next lecture, let's keep exploring the construct method. In this lecture, we're going to look at an alternative solution to setting the values of a property from the construct function. A new feature called constructor property promotion was introduced in PHP 8. It's a shorthand syntax for performing the exact same logic we're performing in the construct method. In our construct method, I'm going to add the public keyword to the parameters of the construct method. For readability, I'll put these parameters on new lines. By adding the access modifier to the method, PHP does two things. Firstly, these are not just parameters anymore. PHP treats these parameters as properties for the class. Secondly, the values for these properties are set with the values passed into the construct method. As a result, we don't need to define the properties at the top of the class. Nor do we need to set the properties from within the construct method's body. We can rename the parameters to name and balance. If we refresh the page, our code works as before. There are three things to keep in mind. Firstly, this feature is only available in PHP 8 and above. If you're using an older version of PHP, you cannot use this feature. Secondly, you must add the access modifier to the property. Otherwise, PHP treats the parameter as a regular parameter. Lastly, you don't always have to use this shorthand syntax. There are cases when you'll want to define the properties but don't want them to be modified through the construct method. If that's the case, you can define additional properties at the top of the class. Not every property needs to be configurable. Alright, that's it for now. In the next lecture, let's start talking about custom methods. In this lecture, we're going to define custom methods for our class. Magic methods are not the only type of functions that can be defined in a class. Custom methods can be created from our class. But why would we want to define a custom function from within a class instead of outside of a class? Let's find out why. In the account class, let's add a function for depositing money into our accounts. At the bottom of the class, define a public function called deposit. Similar to magic methods, custom methods must have an access modifier. Since the goal of this function is to update the balance, we must accept the amount to deposit. In the parameter list, add a float parameter called amount. Next, inside the function, update the balance property with the amount parameter. For this example, I'm using the shorthand syntax of adding a value to an existing number with the addition assignment operator. As a reminder, we must use the this keyword. This leads us to the reason why we would want to define a function inside a class. Being able to access an instance's properties is probably the biggest advantage of defining a function from within a class. We never have to worry about affecting other instances. Let's try calling this function. Head back to the index.php file. Before dumping the balance, let's call the myAccountDeposit method. Calling a method is similar to accessing a property. The arrow can be used for accessing properties or methods. Let's pass in a random number to the deposit method. In the preview, our balance gets updated. Perfect. We've got a custom method for updating the balance. We can take things a step further with a feature called method chaining. Let me show you an example. What if we want to perform multiple deposits to the same account? After the deposit method, call the same method again with a different value. This solution works, but it can be improved. Typing the variable followed by the method can be tedious. It's not uncommon to call multiple methods from the same class. Rather than accessing the instance over and over again, it would be nice if we could call the deposit method immediately after the first invocation. Well, that's possible with method chaining. Head back to the account class. Inside the deposit method, return the this keyword. By returning the this keyword, we can access the instance's properties and methods again after calling a method. Back in the index file, we can shorten our code like so. Here's what's happening. First, PHP calls the deposit function, which increases our balance. Afterward, the instance gets returned from our function. So, we can immediately chain another function since the return value is the instance. In the preview, our balance reflects our actions. Method chaining is a convenient feature for calling multiple methods from the same class. It's not required, but can make your code readable. There's one thing to keep in mind. You should never forcefully return the instance from all your methods. Initially, it might seem tempting since it gives you readable code. However, it can prove to be a problem if your function needs to return other types of data. Generally, you should only return the instance if it's easy to do so. Forcing your functions to return the instance is just a lot of hassle. In the next lecture, let's talk about an operator related to objects. In this lecture, let's talk about the null-safe operator to help us avoid errors. Not all variables are going to have an initial value. For example, the myAccount variable may not contain an instance of an account until a later point in our application, so the initial value of our variable can be null. Unfortunately, that can cause issues. If we attempt to access a method or property on a variable containing null, PHP throws an error. The error states the following: call to a member function on null. Whenever encountering this error, PHP is attempting to tell you that the object you're trying to access doesn't exist. One solution would be to use a conditional statement with the isSet function. If our variable contains a null value, PHP returns false. As a result, the deposit function never gets called, thus avoiding the error. This is a completely valid solution that you may see from time to time in older projects. However, it can be cumbersome to repeatedly type conditional statements. For a while, this was our only solution. Luckily, the PHP team has introduced an alternative, shorter solution for performing the same action. In PHP 8, the null-safe operator was introduced. It's easy to use. In our code, before the arrow, add the question mark character to all cases where we access the myAccount variable. By adding the null-safe operator, PHP checks the value on the left for a null value. If the variable is null, PHP does not execute the code on the right. Looking at the preview, the error has gone away. If we attempt to output a variable with this operator, PHP returns null. Keep in mind, this operator is only applicable to objects. We can't use it on variables with other data types, such as strings or arrays. In my opinion, it's easier to read and write code with the null-safe operator instead of using a conditional statement. We'll be using it often in our script. In the next lecture, let's take a moment to talk about namespaces. In this lecture, let's talk about one of the most crucial features of PHP, which are namespaces. Namespaces are entirely optional. You can create an application without ever using custom namespaces. On the other hand, you might want to consider using a namespace to keep your project organized. Let's explore why. First, let's understand the concept of a namespace. Namespaces are a common feature in most programming languages. Therefore, they're not specific to PHP. You can carry this knowledge to other areas. A namespace can be thought of as a virtual folder for your code. Code organization is considered to be a huge priority for developers. If you've ever spoken with an experienced developer, one of the pain points of development is organization. Unorganized code is difficult to work with. If you're creating a small application, it might not seem like a big deal. Once you start working on medium to large size applications, it can become a nightmare to manage thousands of lines of code. To understand why, let's talk about folders. On your system, you may have folders for music, pictures, and videos. Technically, you can store various file types from within a single directory, but that would be inefficient. Finding files would take a while. Most people organize their files into folders. The most significant advantage of using folders is reusing file names. For example, let's say we are wedding photographers. Every wedding has a cake. To keep our project organized, each wedding may have a folder with a file called cake.jpg. These are duplicate file names. If these images existed within the same folder, our system would not allow them to have the same file name. However, since they're in separate directories, we can repeat file names without conflicts. This is the advantage of using folders. Without folders, we would have to be creative with our file names. This same idea applies to programming. Namespaces are the solution for organizing the names in our code. You can think of them as virtual folders for your code. In some cases, you may want to repeat class names. For example, what if we want to create a class for user accounts and bank accounts? Unfortunately, Most programming languages do not allow duplicate names, which can force us to be creative with our names. By using namespaces, we can avoid these types of conflicts. Namespaces are an optional feature of PHP. In general, they're heavily adopted within PHP and the programming community. It's in our best interest to start creating namespaces. In the next lecture, let's create a namespace. In this lecture, we're going to create a namespace for the account class. A namespace can be created with a single keyword. We must define a namespace at the top of the PHP file. However, if we have strict typing enabled, it's perfectly fine to define the namespace after the declare statement. Let's add the namespace keyword. Next, we must provide a name for our namespace. The rules for naming functions or classes apply to namespaces. It's considered standard practice to use Pascal casing for your namespaces. Let's set the name to app. Just like that, we've created a namespace. Behind the scenes, PHP puts our class in a virtual folder. It's not a folder you can navigate to with your file system. It's more like a folder temporarily created in memory for your class. We're not limited to a single folder or namespace. If you're working on a larger application, you may want to consider nested namespaces. For example, let's change the namespace to app\bank. I'm using a backslash character, not a / character. Frequently, I find beginners use the incorrect character in namespaces. Whenever we use namespaces, we must always use the backslash character. There isn't a limit as to how many levels we can go. Generally, most developers never exceed more than 2 levels of namespace. It's like if you had a complicated folder structure on your system. Managing your code is easier when you have 1 or 2 layers. For this example, I will keep it simple with the app namespace. Now that our namespace is ready, how does it affect our code? To find out, let's modify the index file. Previously, we updated the myAccount variable to be null. Let's change the value to a new instance of the account class. I'm going to pass on random values to both arguments of the class. After doing so, we get an error. Our class isn't working like it did before. To understand why, we must look closely at the error. It says the account class was not found, which might seem strange. Technically, we're including the account file with the require once keyword. The reason has to do with the namespace. It's not enough to just include the file. We must also reference the class through its namespace. Before creating the instance, include the namespace. Voila! The error has gone away. By placing a class inside a namespace, the namespace must be included during instantiation. Now you may be thinking, this is kind of annoying. It's extra code to write. Luckily, we can import a class with the use keyword. Below the require statement, add the following: use app\account. The use keyword allows us to import a specific class from a namespace. By doing so, we don't have to fully type the path to the class whenever we create a new instance. Whenever accessing a class, PHP checks if the class exists within the imported namespace. If it does, it'll grab the class from that location. So, we can remove the app from the instantiation. Our code continues to work. PHP can create an instance without a problem. Great! There are a few more things I want to mention about namespaces, but we're running short on time. So, let's talk about it in the next lecture. In this lecture, we're going to continue our discussion of namespaces. There are some gotchas and good practices you should be aware of when using them. First and foremost, the account class is defined in the root directory of the project. If we were to look at the file tree, our project is starting to get cluttered. For the best developer experience possible, we should try using folders. In our project, create a folder called app. Next, move the account file into this folder. Lastly, in the index file, we must update the require statement to load the file from the corresponding directory. The application should continue to work. You may have noticed, but the name of the directory and namespace match. This step is not required. Namespaces and directories don't have to have matching names. However, it's considered good practice. Let's say you opened a file that imports a class from a namespace. It's possible that the class may be producing errors. Naturally, you may want to open the file with the class to fix the errors. Large applications may have dozens of directories, which can make it harder to find files. To make it easier to find a class from a specific namespace, developers will keep the namespace and directory names consistent with each other. It's a practice we'll be following as well, so that's the first thing I wanted to cover. Another key concept you should know is that importing classes from the same namespace are not necessary. Let me show you an example. Nowadays, most applications allow you to tie your social media accounts to your main accounts. I think it would be a good idea to dedicate a class to that feature. In the app folder, create a file called socialmedia.php. Next, add the app namespace to the file. Multiple classes are allowed to occupy the same namespace. However, it's important to note that duplicate class names are not allowed unless they're in different namespaces. Let's define a class called social media. Our class is ready. Let's load it before using it. Switch over to the index file. Below the other require statement, add another require once statement for the social media file. Great. The last step is to use this class. Typically, we would create a variable in the index file for storing the instance. However, since social media accounts are associated with an account, I think it would make sense to store that information as a property of the account class. In the account class, let's define a property for storing an instance of the social media class. The property will be called social media. Next, set the data type to social media. It's perfectly valid to use a class as the data type. By doing so, PHP can restrict the value assigned to the variable to instances of the class. If we attempt to assign a different value, an error would be thrown. In addition, we're not including the namespace. Normally, the namespace would have to be included. However, since the social media class occupies the same namespace as the account class, PHP is able to resolve the class. Whenever we use a class, PHP checks the current namespace for the class. As a result, we don't have to specify the full path. Let's create a new instance. Inside the construct method, set the this social media property to a new instance of the social media class. As you can see, our application continues to work. Resolving namespaces can be a tricky business. In the resource section of this lecture, I provide a link to a documentation page with more information on this topic. PHP goes through many rules to check where a class is defined. I'm not going to be able to go through every rule, so I highly recommend checking out this page for a complete breakdown of this feature. If you need more examples, PHP has a FAQ on namespaces. I also provided a link to this page in the resource section. If you look through the questions, you'll come across examples of how PHP resolves different namespaces. They're worth checking out too. With that being said, there are a few more things worth mentioning about namespaces. Let's head back to the index file from our project. Below the My Account variable, I'm going to create a new instance of a class called datetime. PHP doesn't just provide us with predefined functions. There are a set of predefined classes available to us. If we are interested in working with dates and time, we can use a class called datetime. In most cases, PHP doesn't place its classes inside a namespace. Classes that aren't in a namespace are considered to be in a global namespace, which is why we don't have to add the use keyword. In the preview, the app continues to work despite not assigning the instance to a variable. PHP creates the instance and then destroys it. However, watch what happens when we create an instance in the account file. I'll move this line of code to the account file, below the namespace statement. This time, PHP is unhappy. Looking at the error, PHP states the class can't be found, which is strange. The class is defined by PHP, so shouldn't it be available? The answer to our question lies in the quotes from the error message. PHP is attempting to search for the class from the app namespace. By being in a namespace, we're no longer in the global namespace. PHP doesn't bother checking the global namespace since we're in a custom namespace. The date-time class does not exist. To fix this error, we must tell PHP to search for this class from the global namespace. That's simpler than you can imagine. Before the name of the class, add a / character. Adding this character resolves our issue. If we were to add this character without a namespace before it, PHP automatically resolves the class to the global namespace. An alternative solution is to use the use keyword. Above the instance, add the use keyword with the date-time class. Next, we can safely remove the / character. This works too. The use character can be used for resolving classes to the global namespace, not just our custom namespaces. One thing you'll notice is that we're adding the use keyword from the account file, but not the index file. Importing classes must be performed from the file where they're being used. Since we're using the date-time class from the account file, we must add the use keyword to this file. Let's see what happens when we don't do that. I'll move this line of code over to the index file. As you can see, PHP throws an error. Despite loading the index and account files, PHP does not recognize our import statement. The date-time class gets resolved to the app namespace, not the global namespace. I'll revert these changes to fix this error. Another cool feature of namespaces is aliases. Aliases are a feature for renaming a class after importing it. You may want to use an alias for two reasons. Firstly, if you're importing classes with the same name, using an alias can prevent PHP from throwing an error. Secondly, some classes can have really long names. It can be annoying to type out the entire name, so creating a shorter name can help with readability. Let's apply an alias for the date-time class. An alias can be applied by adding the as keyword to the import statement. Following this keyword, we must add a name for the class. Let's use the letters DT. Next, we can use DT instead of date-time like so. This works just as well. Aliases are an optional but handy feature. Alright, one more thing before we move on. Switch over to the index file. Currently, we're importing the account class. But what if we would like to import the social media class? Well, we can add a use statement for this class like so. This works, but there's a shorter way of importing multiple classes from the same namespace. Let's remove the second use statement. We can import multiple classes by wrapping the class with a pair of curly brackets. Inside these brackets, we can provide a list of classes by separating them with commas. So, if we want to import the social media class, we can import it like so. You may prefer this syntax instead of repeatedly typing the entire namespace for each class. So, that's about it for namespaces. In the next lecture, let's make some improvements to our code by using auto-loading. In this lecture, we're going to begin auto-loading our classes. Let's take a look at the index.php file. Currently, we are requiring each class. It's only 2 classes, so it doesn't seem like that big of a deal. The thing is, once you start working on larger projects, continuously loading files can become tedious. Before you know it, you can have a large file filled with require statements. Since object-oriented programming is popular with PHP developers, there's a function for automating this process. Let's give it a shot. First, apply a comment to the require statements. Alternatively, you can completely remove them from your script. We're not going to need them anymore. Next, invoke a function called SPL autoload register. This function is defined by PHP. It has a few parameters, but we're only going to focus on the first parameter, which is a function to execute. Let's pass in an anonymous function. Whenever we use a class, PHP searches for the class definition. If it can't find the class, it'll execute the function passed into the SPL autoload register function. This behavior gives us the opportunity to load a class required by our program. Before doing so, we must know what class to load. This information is passed on to our function. In the parameter list, add a parameter called class. Next, call the variable dump function with this parameter. In the preview, an error gets thrown. This is because we aren't loading the account class. PHP is not able to create an instance of our class until we've loaded the file with the class definition. However, there's another thing worth noticing. The class parameter gets rendered before the error gets displayed. This result tells us that our anonymous function gets executed before PHP throws an error, which is a good thing. We have an opportunity to avoid disaster before PHP stops executing the script. Let's use this opportunity to load our file. Looking closely at the output, PHP is rendering the class with the namespace. This is not the system path to the file. If we had a different namespace, we would get a different result. This is another reason why developers prefer to keep the namespace and directories consistent with each other. It makes auto-loading easier. However, there is one problem with the class. PHP does not allow / characters in the require statement. The first step is to replace the / character with a / character. Inside the function, define a variable called formatted class with an initial value of a function called string replace. The string replace function allows us to replace a portion of a string with another string. The first argument is the string to replace. Let's pass in a string with two / characters. Throughout this course, I've told you that any type of character can be inserted into a string without consequence. There is one exception to this rule. If we type a / character, PHP performs something called escaping. Escaping is the process of instructing PHP to ignore a closing quote. As we know, by typing another quote, PHP closes the string. What if we want to write a double quote from within a string like so? Since the string begins with a double quote, the string must end with a double quote. However, that means that we have a third double quote hanging around, which causes an error. If we want the second double quote to be included in the string, we have two options. The first option is to switch to single quotes. The second option is to apply a / character before the second double quote. By adding this character, we're escaping a string. It's another way of telling PHP that the second double quote does not end the string. So, back to our original value. If we were to write a single / character, PHP does not end the string. That's not what we want. To avoid this issue, we can write two / characters to override that behavior. As a result, PHP treats this as a single / character. Moving along, let's pass in a / character as the second argument to the string replace function. If PHP finds a / character, it'll get replaced with the string passed into the second argument. The last argument is the string to search through. Let's pass in the class parameter. Great! Our next step is to generate a full system path to the file. Define another variable called path. Set it to the following value, formatted class.php. All we're doing is appending the extension to the path. Now that we have our path, we can load the file with the require keyword. If we refresh the page, the errors have gone away. We've successfully auto-loaded the class. If we have more files with classes, we can completely avoid requiring each file. Keep in mind, this behavior only applies to classes. If we have regular functions inside separate files, Those files must be manually loaded. Alright, in the next lecture, let's keep exploring topics related to object-oriented programming. In this lecture, we're going to quickly talk about constants in classes. Classes can have constants, but only with the const keyword. PHP provides two solutions for defining constants, which are the const keyword and define function. However, the define function cannot be used in a class. We may only use the const keyword. For example, let's add a constant to the account class. In this class, define a constant called interest rate. Its value will be 2. Constants can have an access modifier. If we don't apply an access modifier to a constant, the modifier defaults to public. This doesn't just apply to constants, but properties and methods. However, it's always recommended to add an access modifier for extra clarity. Let's add the public modifier. Now, the question is, how can we access the constant's value? It's not the same as accessing a property or method. PHP has a special operator for accessing constants from within a class. Let's switch over to the index file. Previously, we called the variable dump function to view the balance. Let's replace it with the following: myaccount, : interest rate. The two colon characters are known as the scope resolution operator. This operator can be used to read constants from the class. In the preview, the constant's value gets rendered. Awesome! Now here's where things get interesting. PHP allows developers to access constants without an instance. Replace the myaccount variable with the account class. This produces the same result as before. So, what are the differences? Truthfully, there aren't any differences. It's just a different way to access a constant. In most cases, developers prefer to access constants without an instance. This way, if the variable disappears, our code continues to work since the class can still exist. So, that's how we can use constants in a class. In this lecture, we're going to learn about different ways of defining properties or methods. From a previous section, we talked about static variables. As a reminder, static variables are variables that can be defined in functions without losing their value. Once a function finishes running, PHP removes the variable from memory. On the other hand, static variables stay alive after a function finishes running. We're not limited to using static variables from within functions. Static properties and methods can be used from within a class. In our account class, let's create a static property by typing the following: public static integer count equals 0. By adding the static keyword, we've created a static property. The static keyword can be positioned before or after the access modifier. If you decide to add it before the modifier, that's fine. The most important thing is to be consistent. Static properties are similar to constants. They can be accessed without an instance. The main difference is that we're allowed to modify the value of a static property anytime we want. For example, let's update the count property whenever an instance of the account class gets created. In the construct method, type in the following: self-scope resolution operator count++. I'm introducing a new keyword called self. Like I said before, an instance of the class does not need to exist to access the class. Typically, we would use the this keyword. However, the this keyword can only be used when referring to a specific instance. Since an instance is not guaranteed, we must use a different keyword for static properties called self. The self keyword points to the class. It gives us access to the static properties. Let's try accessing the static property. Switch over to the index file. In the variable dump function, let's replace the value passed in with the account scope resolution operator $count property. When accessing properties with this operator, we must include the $sign character. If we look in the preview, the property has been updated to 1. Alternatively, we can also access the static property through an instance. Instead of using the account class, Let's replace it with the myAccount variable. That works just as well. Overall, static properties can be used for storing global data. However, many developers don't like static properties for the same reason. Global variables are considered to be dangerous since they can be changed anywhere in our program. Generally, it's ill-advised to use them unless you absolutely have to. With that being said, static methods can be more useful than static properties. Let me show you an example. In the app folder, add a file called utility.php. Next, add the app namespace. Afterward, let's define a class called utility. It's common for developers to have a class or two dedicated to utility functions. These are functions that are generic and can be used in a variety of scenarios. They're not functions that need to be tied to a specific class or instance. But why would we use a class if they're just regular functions? Well, as a reminder, we have auto-loading enabled. If we had regular functions, PHP would not auto-load those functions. We must manually include them. However, if those functions exist in a class, we can benefit from auto-loading. At the same time, we don't want to create an instance of this class. This class should contain static methods only. Similar to static properties, static methods don't require an instance of the class to be accessible. In this class, define a public function called printArray. Next, add the static keyword after the access modifier. Just like that, we've got a static method. The goal of this method will be to neatly print an array. Let's accept the array as a parameter called array. Be sure to set the data type to array. Next, echo a pair of pre-formatted tags. In between these tags, call the printar function with the array parameter. Great, our function is ready. Let's give it a try. Back in the index file, let's import this namespace in the use statement by including the utility class. Lastly, let's call the utility printArray method with the scope operator. In this method, let's pass in an array of random numbers. Just like that, we've got a simple utility method for neatly printing an array of values. This is how I usually use static methods. I rarely ever use static properties, but you may come across them from time to time in other projects. In the next lecture, let's move on to another topic of object-oriented programming. In this lecture, we're going to get into a discussion on object-oriented programming principles. So far, we've explored the various features of classes. That's great and all, but how do we properly write classes? There are 4 principles of object-oriented programming to adhere to during development. They're encapsulation, abstraction, inheritance, and polymorphism. Honestly, it sounds intimidating. No worries, I'll try my best to break down each concept throughout the course. Let's start with encapsulation. Encapsulation is the idea of restricting data and methods to a single class or object. Take the following example. We have a variable called amount. This variable gets updated from the foo function. This flexibility seems great at first, but can cause issues. Since our variable is available globally, it can be updated from anywhere. That's not something we may want. It can be difficult to debug variables that can be updated anywhere. If a variable has an incorrect value, we must track down where it was updated to fix the bug. The larger your code base, the longer it'll take to track down the bug. Encapsulation resolves these issues. By defining a variable from within a class, we can restrict the variable's access. This feature is known as encapsulation. Implementing encapsulation is easier than you think. Let's take a look at the account class. In the construct method, we have 2 properties called name and balance. Thus far, we've been setting the modifier to public. Let's try changing it to private. By using the public modifier, A property or method is accessible inside the class and outside of the class. Technically, we don't have to use the deposit method to update our amounts. We could have directly updated the balance property from our instance. In that case, public properties are just as vulnerable to problems as global variables. Changing the modifier to private prevents the property from being accessed outside of the class. We won't be able to read or update the value. It's only accessible to the current class. So, our deposit method will continue to work as before. This is the power of encapsulation. If the balance property has an invalid value, we know exactly where the problem can possibly be, which is the deposit method. As a result, it's much easier to debug our program. But what if we want to access the value from outside the class? That's possible with something called getters and setters. First, let me show you what happens when you try to access a private property. Open the index file. Below the myAccount variable, let's remove the clutter below the code. Next, try echoing the myAccountBalance property. In the preview, the interpreter tells us that we can't access a private property. To get around this issue, we can create a getter or setter function. A getter function is a function for returning a specific property from a class. Let's try creating one. Back in the account class, define a public method called getBalance. Getter functions can have any type of name. It's common practice to prefix the function name with the word get, followed by the name of the property that'll be returned by the function. We'll be following this convention. Inside this function, let's return the thisBalance property. Back in the index file, let's echo the value returned by the getBalance method. As you can see, the balance can be read from our class. Now, you may be thinking, what's the point of using a getter when using a public modifier works just as well? Getters give us the ability to format the value before it gets returned. Back in the account class, let's update our getBalance method by adding a $sign character before the balance. This is one of the reasons why you would want to use getters. We can take things a step further by verifying if the user has permission to view this property before returning anything. Alternatively, we can perform a query to a database to retrieve the value. Getter methods give us more flexibility with the value we can return. On the other side of the spectrum, we can define setter methods, which are functions for updating a specific property. Let's create a setter for our balance property. Below our getter method, define a function called setBalance. Similar to getters, it's common practice to use the word set followed by the property name. In the parameter list, add a float parameter called newBalance. Next, let's add a conditional statement to check if the newBalance parameter is less than 0. Preventing a negative balance is a common use case for using a setter. If the newBalance is less than 0, return the method to prevent further execution. Otherwise, we can safely proceed to set the thisBalance property to the newBalance parameter. We've successfully created a setter. Encapsulation is considered to be good practice. By limiting the accessibility of a property, we can constrain how a property can be read or updated. With that being said, there are some problems that can arise with getters and setters. First and foremost, for every property in our class, we may need to define a getter and a setter. As you can imagine, our classes can quickly become bloated. The best way to avoid bloat is to consider if a getter or setter is necessary. You shouldn't automatically create a getter or setter just because a property is private. The only time you should define them is when you actually need to. As long as you define getters and setters as needed, bloated classes can be avoided. There's one last thing I want to mention before moving on. Properties are not the only things that can be private. Methods can be private too. For example, let's define a function called sendEmail with the private modifier. Not all your methods should be public. For example, let's say the user's balance changes. If that's the case, we should send an email. However, that should only happen if the balance is successfully updated. If this method were public, it would be possible to send an email for other occasions, which is something we may not want. By defining private methods, only our class can call this method. For example, let's call this method after updating the balance in the setBalance method. Technically, our method doesn't send an email, but let's pretend that it did for the sake of this example. Now, if our balance gets updated, users will be notified of these changes. Overall, access modifiers are a powerful feature for limiting what can and can't be accessed from our class. In the next lecture, let's get into a discussion on the next principle, which is abstraction. In this lecture, we're going to discuss the next principle of object-oriented programming, which is abstraction. This principle is a little bit hard to nail down, so let's start with the idea of abstraction in real life. Abstraction is the idea of hiding complex details and behavior from the user. Think about it like this. Everyone knows how to use a coffee machine. However, not everyone knows how a coffee machine works internally. We don't know how it heats water or how it grinds coffee beans. That's not something we need to know. Just press a few buttons, and the rest is taken care of for us. The same idea can apply to cars. We know how to drive a car, but not many people know the inner mechanisms of a car. The complexities of both machines are hidden from users. We can apply this concept to programming. Whenever we design a class, we need to ask ourselves, how much does the user of a class need to know about the actions performed by our class? For example, let's say we had a class for connecting a user's account to a social media platform. To perform this type of action, we must complete a series of steps, such as connecting to the platform, asking for permission, grabbing specific information from their account, and then connecting that information to the user's account on our site. We can outsource these steps to a class in our application. Afterward, we can execute a single method to perform these actions. By doing so, we are abstracting the complexities of connecting a local account to a social media account. We have an example of abstraction in our class. The setBalance method can be considered an abstract solution. Before the balance is updated, the method checks if the value is below 0. Then it updates the balance. Lastly, an email gets sent. If another developer were to call this method, they don't need to know how this method works. Their job is to provide a new value. The method handles the rest. That's the abstraction principle in a nutshell. Whenever you design a class, you should always consider what can be performed by the user and what can be performed by the class. Should users know how to send emails or validate data, or do they just need to provide a number? By answering these types of questions, you'll be able to design better classes. In the next lecture, let's get into the next concept of object-oriented programming. In this lecture, we're going to discuss the third concept of object-oriented programming called inheritance. Inheritance is one of the most commonly used features of object-oriented programming. So, what is inheritance? Inheritance is a feature where one class can be derived from another class. But what exactly does that mean? Think of it like this. Children inherit their physical attributes from their birth parents. If both parents have blonde hair, their child is most likely to have blonde hair themselves. Both parents' DNA contribute to the DNA of their child. This idea can be applied to our classes. We can have parent classes that share properties and methods with another class. By doing so, we don't have to repeat our code, thus saving time and boosting productivity. Let's look at an example. Inside the app folder, create a file called toaster.php. Let's apply the app namespace to this file. Next, define a class called toaster. Inside this class, let's define an integer property called slots. Set the initial value to 2. Next, define a method called toast. Within this method, we're going to echo the following message: toasting bread. Overall, we have a class of a toaster with 2 slots for toasting bread. Simple, right? If we're working for a company that sells toasters, they more than likely sell multiple variations of a toaster. For instance, this toaster could be their simplest model. They may have another model with more slots and functionality. In this case, we would have to define another class. Let's give that a try. In the app folder, create a file called toasterpremium.php. Next, copy the code from the toaster class. Paste this code into the toaster premium file. Lastly, let's rename the class from toaster to toaster premium. So, we have 2 classes for building toasters. One class represents a basic model. Another class represents a premium model. The main difference between them will be the slots. The premium model should have more slots. Let's set the slot size to 4. This solution works, but there's one problem. We have duplicate code. It doesn't make sense to have the toast method in both classes. They do the exact same thing. Here's where inheritance can save us a lot of trouble writing duplicate methods. After the name of the class, add a keyword called extends. The extends keyword instructs PHP to inherit properties and methods from another class. So, let's try extending the toaster class. Just like that, the slots property and toast method are available from within the toaster premium class. We don't have to define them. I'm going to remove the toast method. As for the slots property, it's going to remain in the class. If PHP encounters a duplicate property, it'll prioritize the property defined in the current class. Therefore, the slots property will be set to 4 instead of 2. This feature gives us the power to override the properties from the parent class, which is the class we're extending. In addition, we can add additional properties and methods alongside the inherited properties and methods. Let's try using our class. Switch over to the index file. In the use statement, import the toaster premium class. Next, create a variable called myToaster. Its value will be a new instance of the toaster premium class. Lastly, let's call the toast method from the instance. In the preview, the message from the toast method appears. Despite not having a method called toast, PHP found this method from the parent class, which was the toaster class. Thus, our toaster premium class will have the method. There's one thing to keep in mind when using inheritance. The this keyword behaves differently with inheritance. For example, switch over to the toaster class. In the toast method, let's echo the slots property. Looking at the preview, the number 4 gets outputted. Technically, the toast method is defined in the toaster class. So, shouldn't the this keyword point to the toaster class? Not necessarily. The this keyword always points to the current instance. In this case, the instance was created from the toaster premium class. Therefore, the this keyword searches for the slots property from the toaster premium class. It can add a bit of confusion, but something you should definitely be aware of when dealing with inheritance. Alright, now that we have a basic understanding of inheritance, let's get back into a discussion of access modifiers. Inheritance adds a layer of complexity when it comes to access modifiers. That'll be a topic for the next lecture. I'll see you there. In this lecture, we're going to explore another access modifier called protected. There's an underlying problem with the toaster class. Can you spot the problem? The slots property is public. If we think about it, the number of toaster slots is unlikely to change. It's a property that shouldn't be modifiable outside of the class. One solution is to set the property to private. After modifying the modifier, our script behaves differently. Instead of outputting the number 4, we get 2. This is because the modifiers of the slots property are different in both classes. They must match. However, that's not the only problem. If the parent class has a private property, the child class won't be able to modify the property. It's the same reason why the property can't be modified outside of the class. Since the Toaster Premium class is a completely different class, PHP does not allow it to modify the property. Only the Toaster class can. So, we can't use public because that'll expose our slots property to outside sources. But we also can't use private since child classes won't be able to modify the property either. In this case, we can use the protected modifier. In the Toaster class, set the slots property to protected. Next, do the same for the Toaster Premium class. This time, the property gets set back to 4. By using the protected property, we get a behavior in between public and private properties. The property can be modified from the original class or classes that derive from the parent class. At the same time, it can't be accessed or updated outside the instances of a class. In the next lecture, let's talk about calling parent constructors. In this lecture, we will continue talking about inheritance by exploring how methods can be overridden. In a Toaster Premium file, our class has 2 more slots than the basic model. Let's add another feature by allowing users to modify the duration of the toasting process. In the class, define a private integer property called duration with an initial value of 1. By adding a duration, we must update the toast method to use the duration. Otherwise, the property becomes redundant. Similar to properties, our child class can override the methods from the parent class. Let's define the toast method. In this method, let's echo the following message: toasting bread for this duration minutes. In the preview, our function is working as expected. PHP completely overrides the toast method from the toaster class with the method from the Toaster Premium class. With that being said, there are a few things worth noting. Firstly, we may not want to completely override the method. It's possible to have the best of both worlds. PHP allows us to run the method from the parent class and child class. Above the echo statement, write the following: parent scope resolution operator toast. Next, we can remove the beginning portion of our message from the echo statement. In the preview, both methods are executed. The parent keyword provides access to the class that we're extending. This means we can execute methods from the parent class alongside the methods from the child class. One thing you'll notice is that we're calling the parent method before executing the logic of the child method. It's always recommended to call the parent method before doing anything else. Technically, we can run the method at any time. However, you may not always have control over what happens in the parent method, which can cause issues in your own method. For example, let's try updating the toaster class. In this class, let's remove the value assigned to the slots property. Next, define the construct method. Inside this method, set the thisSlots property to 2. All we've done is moved the initialization process to the construct method. Now that we've done so, let's define a construct method in the Toaster Premium class. We'll repeat the same thing as before. Rather than initializing the slots property from the class level, let's do so from the construct method. Lastly, let's call the parent construct method after setting the slots property. One of the most common things to do in a class is to call the parent's construct method. In this example, we're going against the recommendation of calling the method first. If we look at the preview, the slots property is set to 2 instead of 4, which seems strange. In our method, we're clearly setting it to 4. However, since the parent method also sets the property, it overrides the value from the Toaster Premium class. Rather than calling the method at the end of our method, let's move it to the beginning. This time, Our property is being correctly set. The order does matter in these cases. It's always recommended to let the parent run first. If you need to override changes, you should do so afterward. This produces reliable results. At the end of the day, it's up to you when these methods should be called. Let's keep moving along. We're allowed to override methods, but their signatures must always match. Oftentimes, you'll hear the word signature. The method signature refers to the name and parameter list method definition. In this example, the method signature would be some method, some parameter, and another parameter portion of the method. If the method signatures don't match, PHP throws an error. For example, let's update the toast method from the toaster class. Add a parameter called someParameter. If we refresh the page, an error gets thrown by PHP. According to the error, the toast method from the toaster premium class does not match the method from the toast method in the toaster class. Pay close attention to the error. It tells you exactly which class and methods are causing the error. I'll remove the parameter from the toast method since it's not necessary. So, this rule applies to all methods except for the construct method. Let me show you an example. In the toaster premium class, let's update the construct method by adding an integer parameter called newDuration. This parameter will be used for updating the duration. Rather than initializing the parameter from the class level, let's do so from the construct method. First, remove the value from the property. Next, set the thisDuration property to newDuration. Afterward, switch to the index file. In this file, we're instantiating the toaster premium class. Since we have a parameter in the construct method, we must pass in an integer. Let's pass in 3. After making those changes, our script continues to work. The message states that the duration is 3 minutes long. Despite having different method signatures, PHP does not throw errors. This is because it's perfectly acceptable for the construct method to have different signatures across the parent and child classes. There's one more thing I want to show you before moving on. It's completely possible to stop child classes from overriding or even inheriting properties and methods from another class. PHP has a keyword called final that can be applied to classes or methods. Switch over to the toaster class. The final keyword must be applied before the class keyword like so. After applying the keyword, PHP throws an error. It's stating that the toaster premium class cannot extend the toaster class. The final keyword prevents other classes from extending the current class. However, you may not be interested in preventing the entire class from being inherited. The final keyword can be applied to methods too. For example, let's move the final keyword from the class to the toast method. Similar to before, we get an error message from PHP. This time, it states we can't override the toast method, which is what we're doing in the toaster premium class. The final keyword can be a powerful feature, but it's generally something you should use sparingly. There are a lot of developers who believe that the final keyword should never be used because it locks developers in a class's implementation. I'm going to leave it up to you to decide when you should and shouldn't use this keyword. With that being said, this does lead us to an interesting discussion on when to use inheritance. How do you decide when a class should inherit from another class? There's a concept known as an is-a relationship. When you're designing a class that'll inherit from another class, you should ask yourself, does it make sense to say this class is another class? For example, let's say we had two classes called Apple and Orange. Since both classes can be thought of as fruit, they can have properties for how sweet they taste. Rather than duplicating properties, the Orange class can inherit from the Apple class. However, it doesn't make sense to think of an orange as an apple. They share similar information, but don't share every single quality. Instead, we can define a class called fruit. The fruit class can be a generic class that other classes can inherit from. By doing so, we can introduce additional fruit. It makes sense to say that an apple is a fruit and that an orange is a fruit. This is the idea of an is-a relationship, when you can think of one object as another object. That pretty much sums up inheritance. In the next lecture, let's keep exploring other topics. In this lecture, we're going to discuss abstract classes. They're another feature of inheritance. Before we can get into this discussion, there's some terminology we should add under our belts. You're going to hear them a lot in regard to abstract classes, not just for PHP, but for programming languages in general. The first word I want to go over is implementation. This word can have various meanings depending on what you're talking about. For the intents and purposes of this lecture, we're going to think of it like this. It's a function, method, or class written based on an idea. Let's say I had the idea that I wanted a function to say hello world. Here are two functions. The first function does not implement my idea because it doesn't have a body. However, the second function does implement my idea. Therefore, it's completely valid to say that the bar function is an implementation of my idea. Moving along, another definition I want to cover is a concrete class. A concrete class is a class where all its methods have an implementation. If you think about it, every class we've written thus far is a concrete class. Currently, I'm looking at the toaster class. This class is definitely a concrete class. All our methods have a body. We can say the same for the toaster premium, account, or social media classes. They are all concrete classes. That leads us to the last term, which is an abstract class. An abstract class is a class that does not have implemented methods. Alternatively, it can have partially implemented methods. So, you may be wondering, why would we want to use an abstract class? Before I answer that question, let's learn how an abstract class is written. Once we know how an abstract class works, I'll explain why you would want to use one. Let's say the company that builds toasters wants to start selling other types of products. For example, they may want to start selling microwaves. Every product they develop is an electronic. What do all electronics have in common? They must have a consistent supply of power. I think it would make sense to define a method that can be used to turn on an electronic device once it's plugged in. The question is, do we define it in the toaster or toaster premium class? How about in a class for the microwave? Since all electronics are going to need this functionality, we should define it in a separate class that can be inherited. First things first, let's create a file. In the app folder, create a file called abstractproduct.php. Next, add the app namespace. Lastly, add a class called abstractProduct. It's standard practice to prefix your abstract class names with the word abstract. Not required, but recommended to help other developers identify this class as an abstract class. We can use this class as a base class for toasters and microwaves. However, there is one problem. Switch over to the index file. In this file, let's import the abstract product class from the app namespace. Next, above the variable, create a new instance of the product class. If we refresh the page, nothing appears. PHP doesn't throw an error because we're instantiating a regular class. That's not something we want. The product class is a generic base class. It's not tied to a specific type of product. Therefore, we shouldn't be able to create an instance from it. We can avoid this issue by converting the class to an abstract class. Back in the product file, add a keyword called abstract before the class keyword. This time, PHP throws an error. The error states we can't instantiate the product class. This behavior is one of the benefits of using an abstract class. we can prevent other developers or ourselves from creating an instance of a class that shouldn't be instantiated. Instead, this class should be created as a base template for other classes. Let's remove this line of code. After doing so, head back to the product class. In this class, let's define a method for turning on the product called turn_on. In this method, let's echo the following message, turning on product. Our method is ready. Let's try using it. Switch over to the toaster class. After the toaster class name, add the extends keyword to inherit from the product abstract class. Lastly, we can call the turn_on method from the constructor method to turn the toaster on. In the output, the toaster has been turned on successfully. That's great, but why are we using an abstract class? Other than not being able to create an instance, it seems like abstract classes are like regular classes. In the product class, we have a method with an implementation. It's completely optional for abstract classes to have implementations. We can even have a mixture of unimplemented methods and implemented methods. For example, let's add a method called setup. Some methods may require additional setup after they've been turned on for the first time. For example, microwaves may have a clock. They may require users to adjust the clock to their current time zone. We can use this method to set up the product for the first time. However, each product is unique. Not all products are set up the same. They may have different ways of being set up. Therefore, the abstract class shouldn't be responsible for implementing this logic. We can convert the method into an abstract method by adding the abstract keyword at the beginning of the definition. Next, we can replace the curly brackets with a semicolon. Abstract methods don't have to have an implementation. Instead, they can leave that job to child classes. If we look at the preview, an error pops up. According to the error, the toaster class is not fully implementing the product class. It's missing the setup method. PHP always documents which methods are not implemented. Let's try fixing this error. In the toaster class, add the setup method. After adding this method, the error goes away. That's perfect. We've successfully implemented the abstract class. There's one thing to be aware of when using abstract classes. In the abstract class, the methods cannot be set to private. That makes sense, right? As we know, private methods cannot be overridden. So, if we have an abstract method that requires an implementation, using the private modifier results in errors. Instead, you must always use the public or protected modifier. Now this brings us to the question, why would we want to use abstract classes? The answer comes down to developer experience. So far, most of the features we've explored have been for helping us subdivide or control the logic. However, abstract classes don't serve either of those purposes. There are tons of PHP developers who never use abstract classes and are perfectly fine. I don't recommend going down that route. Abstract classes improve the developer experience. As developers, you're going to run into bugs. PHP introduces features into the language, not for speed or security, but to help you catch bugs. Other features can be useful for documenting your code. Abstract classes were introduced for documenting and debugging your code. Let's say you are hired to update an existing banking application. The bank you're working for offers checking and savings accounts, but let's say they wanted to introduce investment accounts as a new product. Regardless of the account, every account has a property for the balance as well as methods for withdrawing and depositing money. Banks are heavily regulated. You may have to follow hundreds of rules to offer a product. Memorizing each of these rules can be tedious. Since each account type shares similarities, an abstract class seems appropriate. By defining an abstract class, PHP will tell you what methods must be implemented for it to be valid. If you end up forgetting to define a specific method, the abstract class will remind you. Thus, you can avoid the disaster of not following regulations. Overall, abstract classes were introduced to make sure that your classes are fully implemented. They can act as reminders in case you forget how to implement a specific class. In the next lecture, let's move on to interfaces. In this lecture, we're going to explore another feature for helping us implement classes. They're called interfaces. Interfaces are similar to abstract classes. We can use them to force our classes to have a specific implementation. Let's explore how they work. Afterward, we'll talk about why we would want to use them. In the app folder, create a file called restaurantinterface.php. Let's imagine we were developing a food ordering app like DoorDash or Uber Eats. Our app may have dozens of restaurants. Through our app, users will be able to order from these restaurants. Each restaurant must be able to prepare food for our customers. If we think about it, do we need to care about how a restaurant prepares food? Restaurants can have various methods of preparing food. For example, one restaurant may cook meat on a grill. Another restaurant may prepare pastries in an oven. Either way, any restaurant that wishes to be available in our app must be able to prepare food. We'll leave the implementation to each restaurant. This is the perfect use case for an interface. Inside this file, add the app namespace. Next, define an interface with the interface keyword. Following this keyword, we must provide a name. Let's set the name to Restaurant Interface. It's considered standard practice to add the word interface as a suffix to help other developers identify an interface. Alternatively, you may find that developers use the letter I at the beginning of the name. For example, we can use the name iRestaurants. Either naming convention is valid. I prefer the former solution because it's the most popular and common approach in the PHP community. After the name, we can add a pair of curly brackets to begin adding methods. There are a few things to understand about interfaces. Firstly, properties are not allowed in an interface. However, we are allowed to use constants. For this example, we're not going to need constants or properties. Secondly, all methods cannot have an implementation. They must be abstract. So, let's add a method called prepareFood. In this example, you'll notice I'm not adding the abstract keyword. By default, all methods are abstract. The abstract keyword is not necessary. Another thing to take note of is that the modifier is public. Methods cannot be private. They must either be public or protected. Now that we have an interface, let's proceed to implement it in a class. Inside the app folder, create a file called restaurant1.php. Add the app namespace. Next, define a class called restaurant1. A class can implement an interface by adding the implements keyword to our class followed by the interface name. Let's implement the restaurant interface. So, why are we using a different keyword for interfaces? Here's where things become interesting. PHP limits the number of classes that a class can extend to one class. However, multiple interfaces can be implemented. Therefore, let's say we wanted to allow customers to book catering services from our app. Any restaurant that wants to offer catering must implement an interface called Catering Interface. Of course, we don't have an interface, so we can remove it from this example. I just wanted to show you how you can add multiple interfaces to a class. After adding the restaurant interface, we must implement the prepareFood method. Let's quickly do that. Inside this method, I'm going to echo the following message, preparing food. Our class is ready to be used. Let's try creating an instance of the restaurant from the index file. In the use statement, add the restaurant1 class. Next, define a variable called restaurant to set a new instance of the restaurant1 class. Lastly, let's invoke the prepare food method. Just like that, the restaurant is preparing the food. So far, it's nothing we haven't done before. By using interfaces, we're forcing classes to define methods. It's exactly like abstract classes. So, why would we want to use an interface? We know how it works, but not why we should use them. Let's answer that question in the next lecture. In this lecture, we're going to explore the final object-oriented programming principle called polymorphism. Previously, we learned about interfaces. We know that interfaces can be used to force a class to have a specific implementation. They can act as reminders to define methods in a class. That's not the only reason we would use them. There's another reason I've been hiding from you, which has to do with the final principle. So, let's talk about this principle and then see how it can affect our codebase. Polymorphism is a principle that states an object can have multiple forms. This name is derived from the words poly and morph, where poly means many and morph means to change. At first glance, that seems strange. How can an object have different forms? Why would we want an object to have different forms in the first place? Those are good questions. To understand polymorphism, we should look at an example. Let's continue building on top of the food ordering app we were building from the previous lecture. I want to create another restaurant. In the app folder, create a file called restaurant2.php. Next, add the app namespace. Afterward, add a class called restaurant2 that implements the restaurant interface. Lastly, add the prepare food method. Inside this method, echo the following message: preparing food from restaurant2. Alright, we have two restaurants. Let's start building a food application by creating a class. In the app folder, create a file called foodapp.php. Like before, add the app namespace and define the food app class. The responsibility of this class will be to instruct the restaurant to start preparing the food. So, let's add the construct method to the class. In the parameter list, add a parameter called restaurant with the restaurant1 data type. Next, inside the body, call the restaurant prepare food method. Our app is ready. The final steps are to create an instance of this class. Switch over to the index file. Let's update the import statement to include the restaurant2 and food app classes. Next, set the restaurant variable to a new instance of the food app class. Lastly, let's pass on a new instance of the restaurant1 class. In the preview, the restaurant notified us that it was preparing the customer's food. It's working as intended, but let's say the customer wants food from the second restaurant. Well, let's try passing in an instance of the restaurant2 class. After switching restaurants, we are given an error. According to the error, PHP says the construct method of the food app class was passed in an incorrect value. It was expecting an instance of the restaurant1 class, but received an instance of the restaurant2 class. That makes sense when we look at the food app class. The restaurant parameters data type is restaurant1, so fixing this should be easy, right? All we have to do is change the type from restaurant1 to restaurant2. This solution works, but it's not ideal. What if we had 20 restaurants in the area? Customers should be able to order from any of them. By using a specific restaurant, customers are locked into a specific restaurant. Our class only works with one restaurant. To remedy this issue, we can use polymorphism. The restaurant parameter shouldn't be set to a specific type of object. Instead, it should be able to accept multiple types of objects. Are things starting to click? As a reminder, Polymorphism is the idea that an object can have multiple forms. In our case, the restaurant object should be able to represent multiple objects, or, to be more specific, instances of restaurant classes. The question is, how? Well, it turns out that we're not limited to using a class as a data type. Interfaces can be utilized as a data type too. So, let's set the data type to the restaurant interface. Here's what will happen. When we pass in an object, PHP notices that the data type is an interface. As a result, it'll check if the object implements the interface. If it does, it'll allow our function to continue executing its code. Otherwise, it'll throw an error. In the preview, everything is working as before. Let's see what happens when we change the restaurant again. In the index file, pass in an instance of the restaurant1 class. Once again, the class is working. This is because both restaurants are implementing the restaurant interface. As long as a class is implementing this interface, our food app class won't complain. That's the beauty of polymorphism. We have a parameter that can accept various classes. So, you may wonder, is it possible to apply the polymorphism principle with abstract classes? The answer is yes. Polymorphism is possible with abstract classes and interfaces. That brings us to the question, what are the differences between both features? Firstly, methods in abstract classes may have implementations, whereas interfaces cannot have implementations. Secondly, properties are allowed in abstract classes. Interfaces are restricted to constants and method definitions. Properties are not allowed. In addition, abstract classes may have private, public, or protected methods. On the other hand, interface methods are restricted to the public. Lastly, only one class can be extended with abstract classes. Multiple interfaces can be implemented in a single class. Overall, polymorphism is one of the main reasons you would want to use interfaces or abstract classes. Which one should you use? Deciding which to use will depend on your needs. If your methods need implementation, go with abstract classes. Otherwise, you'll be fine with interfaces. It's something you will learn with experience. We've successfully learned all 4 principles of object-oriented programming. In the next lecture, let's continue our journey of PHP. In this lecture, we're going to explore a feature called anonymous classes. Anonymous classes are similar to anonymous functions. They're classes without a name. First, let's look at how we can write an anonymous class, and then we'll talk about why we would want to use them. Let's continue working on our food ordering app. Imagine there's a music festival in our area. Music festivals can attract food vendors. However, food vendors are only going to be around for a few days. Let's say they wanted to allow people to order food from our app. Since they're not going to be around for very long, I don't think it's worthwhile to have a dedicated file for the restaurant. To save time, we can use an anonymous class. In the index file, replace the new instance of the restaurant class with the following value, new class curly brackets. Just like that, we have an anonymous class. Anonymous classes support every feature of a regular class. We can extend another class, implement interfaces, add properties, and define methods. In this case, we're going to receive an error because the class does not implement the restaurant interface. Let's import the interface from the use statement. Next, implement this interface in the class. Afterward, define the prepareFood method. Lastly, let's echo the following message, pop-up restaurant preparing food. After making those changes, the errors have gone away. The anonymous class is completely valid. We can take things a step further by passing on data to the instance created from our anonymous class. Let's say we wanted to configure the name of the restaurant. In the class, add the construct method. Within the parameter list, let's add a public string parameter called name. Inside the prepareFood method, Update the string by injecting the thisName property into the message. From the preview, we're going to receive an error. This is because our construct method expects a string to be passed in for configuring the name. So, how do we pass on data to our class? A pair of parentheses can be added after the class keyword. Inside these parentheses, we can start passing on arguments. Let's set the name to Pop-Up Restaurant. Awesome! The errors have gone away. Like I said before, anonymous classes are just classes without names. So, why would we want to use them over regular classes? There are 3 reasons for doing so. Firstly, they're convenient. As we saw from our own example, we didn't have to take the time to create a new file for another class. This behavior allows us to prototype a class before committing to a regular class. Quick and easy. Secondly, they can be useful for testing. Testing is a subject we haven't gotten around to discussing. However, anonymous classes can be useful for temporarily creating classes that can be used in tests. Lastly, anonymous classes are slightly faster than regular classes since they don't have to be auto-loaded. Auto-loading does require a bit of resources to get done since we're dynamically loading PHP files. However, the differences in speed are negligible. Overall, anonymous classes aren't super popular, but you may need them occasionally. If you ever decide to start learning Laravel, which is a PHP framework, you'll likely encounter them. In this lecture, we're going to explore a PHP comment called a doc block. They've been around for a long time and are heavily adopted within the community. You're likely to encounter them when viewing existing PHP projects. So, what are doc blocks? A doc block is a formatted PHP comment for documenting classes, properties, and methods. If you're using a text editor, like PHP Storm or Visual Studio Code, these editors can read doc blocks to understand our codebase. They can provide useful information for helping you understand a codebase. Let's look at an example. In your editor, open the utility.php file. It's been a while since we've created this class. As a refresher, we created this class for neatly printing an array onto the page. Let's try applying a doc block to the printArray method. A doc block is similar to a multi-line comment. Above the method, add a multi-line comment with an additional asterisk character after the opening multi-line comment. By adding this single asterisk character, most editors will interpret this comment as a doc block. Information written inside this component should be related to the method it's above. In this case, the doc block will apply to the printArray method. Below the opening multi-line comment, add another asterisk. The formatting matters a lot. For every new line in your doc block, an asterisk character should appear. It should be aligned with the first asterisk character from the opening multi-line comment. Inside this comment, we can provide a summary of our method. Let's write the following. Neatly prints an array. The first portion of a doc block is a summary of the method. The summary should always be 1 sentence long. You want to be short and concise. Next, add 2 more lines. Make sure they're formatted like the first line. Sometimes, a summary may not suffice for our method. If you want to add a longer description of your method without limits, you can add a description below the summary. The summary and description must be separated by a new line. Let's write the following for the description. Outputs an array surrounded by pre-tags for formatting. Let's add 2 more new lines. Afterward, we can start providing information on the parameters of our method. This information must be written as a tag. Tags always start with the @ character. The first tag we'll be using is the param tag. Following this tag, we must set the data type, which must match the parameter. Set the data type to array. Next, we can provide the name of the parameter. Lastly, we can provide a description of the parameter. I'll use the following description, the array to output. A description is completely optional. However, I always recommend documenting your parameters to help other developers understand your code. We're finished. We've created our first doc block. All a doc block does is document our code. There are tools available for scanning our code base for doc blocks. They can use them to generate documentation that can be viewed by others. It doesn't actually affect our code base unless we install additional tooling. In the resource section of this lecture, I provide a link to a guide on doc blocks. This site provides more information on the various things you can write in a doc block. I think one of the most useful sections is the tags reference. If you scroll through the page, you're going to come across a section called List of Tags. You can document things from parameters to return values. However, you may want better descriptions and examples. Below the list of tags, there's a link called Tags Reference. Click on it. This will take you to another page with better documentation for each tag. For example, let's click on the parameter tag. As you can see, there's a better description along with an example you can check out to learn from. Now, with all that being said, there's one thing I should mention. As the years go by, doc blocks are becoming less popular and necessary. Let's look back at our code. If you think about it, it's sort of redundant to document the parameter name and data type. Doc blocks were introduced because PHP did not support type hinting for its parameters. It's a relatively new feature. Doc blocks were created long before PHP introduced better type support. I decided to talk about doc blocks for two reasons. Firstly, you're not always going to be working with the latest version of PHP. If you come across a project on an older version, you're likely to encounter doc blocks. Knowing what they are and how to read them will be beneficial. Secondly, doc blocks can help add a description to your parameters, even if it's redundant to add the name and data type. Human-readable descriptions are helpful for developers on your team. Without these descriptions, your teammates would have to read your method to completely understand what it does. Instead of making them do that, you can just provide a description to summarize what the method does. Overall, doc blocks are likely to stick around. I highly recommend checking them out for more info. For now, the basics will suffice. In this lecture, we're going to start moving away from custom classes to exploring classes offered by PHP. One of the topics we've only talked about from time to time is errors. So far, every error we've encountered has been thrown by PHP. Let's talk about the word throw. Why do we say throw an error? The reason we use the phrase throw an error is because it implies that an error can be caught. As we know, errors cause our script to stop working. Initially, that's helpful for development. Eventually, we're going to want to override this behavior for users so that their experience isn't disrupted. PHP provides us the option of catching an error to customize the output. Before we get into catching errors, let's learn how to throw errors. PHP is not the only one who can throw errors. Sometimes we might need to throw errors. There's a class available for performing this exact behavior. Let's give it a try. Inside your editor, open the utility class. We created this class to help us print an array. Let's try improving the solution by validating the array. At the moment, we have strict typing enabled from the index.php file. If we attempt to pass in a non-array value, PHP throws an error for us. However, it's possible for us to pass in an empty array. If an empty array gets passed in, I don't see a point in printing the array. Rather than just printing an array, let's notify the developer that they're passing in an empty array by throwing an error. Add a conditional statement with the following condition: count array equals 0. The condition we've written is very simple. We're using the count function to count the items in the array. If the count function returns 0, this means the array is empty. Inside the block of code, write the following: throw new \exception. I'm introducing a new keyword called throw. The throw keyword allows our program to throw an exception. Throwing an exception causes PHP to start looking through our script for code that can catch the exception. If an exception is not caught by us, PHP falls back to its default behavior, which is to display the error on the page. In addition, the script stops running. After the throw keyword, we must provide an instance of the exception class. The exception class is defined by PHP in the global namespace. Since we're inside a custom namespace, we must instruct PHP to look for this class from the global namespace with the / character. The exception class can help us with formatting the error message by including the file that threw the error, the line of code where the error can be found, a stack trace, and other pieces of information. Basically, an exception is an object to describe the error. It can be used to disrupt the flow of logic from within your application. Typically, you're going to want to write a custom message to help developers. We can pass that in as an argument to the constructor function. Let's write the following message. Array is empty. Great. Let's try using our custom exception. Switch over to the index file. Let's replace the food application example with the utility print array method. Pass in an empty array. Just like that, we've got an exception. In the error message, you should be able to find your custom message, along with the custom message. Additional information about the error can be found. We didn't have to generate this info ourselves. The exception class can be helpful with filling in the blanks for us. With that being said, the exception class is considered to be useful for generic errors. There are other classes available for throwing exceptions. In the resource section of this lecture, I provide a link to a list of exception classes defined by PHP. You can look through each exception to learn more about them. To save time, I think the best exception for our case is the invalid argument exception class. This exception is useful for when an invalid argument is provided in your method, which sounds exactly like our scenario. Switch back to the editor. In the utility class, replace the exception class with the invalid argument exception class. Looking at the preview, nothing really changes. It's the same error as before. The main difference is that the type of exception has changed from exception to invalid argument exception. So, you may be wondering, what are the differences between the exception class and the other classes? To understand the differences, we should look at the documentation. Head over to the list of exceptions I've provided. Click on the link for the invalid argument exception class. On this page, we're given a brief overview of the class definition. Look closely at the first line of code. Notice anything? The class is extending a class called LogicException. Click on the link to this page. Once again, we're provided the class definition. This time, the LogicException class is extending a class called Exception. Therefore, the invalid argument exception class is also extending the exception class. This is true for any exception class. All classes extend the exception class. That explains why we get the same output, but doesn't explain why we would want to use different classes. There are two reasons for doing so. Firstly, you can think of the other classes as specific categories for errors. By using a specific exception, as developers, we can make assumptions at what could be the problem based on the exception. Every piece of information matters for debugging. The second reason is being able to handle exceptions differently. As I mentioned at the beginning of the lecture, we're able to catch exceptions. What if we want to perform different actions based on the type of exception? For one exception, we can respond by redirecting the user. For other exceptions, we can render a message to the user. By categorizing each exception, different responses can be provided. Overall, it's always good practice to be specific with your errors. If you don't know what exception to use, that's perfectly fine. You can always fall back to the exception class. We're not limited to PHP classes. We can create our own exceptions. In the next lecture, let's explore how to do that. In this lecture, we're going to create a custom exception. It's not uncommon for developers to write custom exceptions. You're likely to encounter custom exceptions in frameworks like Laravel. Creating a custom exception is easier than you think. In the resource section of this lecture, I provide a link to the exception class. Similar to how PHP creates exceptions, Creating a custom exception is as simple as extending the exception class. Whenever you're extending classes, I always recommend checking out the documentation for that class. It'll give you information as to what properties or methods you can override. For example, the exception class allows developers to override the message property. After all, the access modifier is set to protected. On the other hand, the string property is not overridable since the modifier is set to private. Moving along, there are additional methods at our disposal. Something to keep in mind is that methods with the final keyword are not overridable. Despite having the public keyword, the final keyword prevents child classes from overriding these methods. This is why it's always good to carefully read the documentation. Information like this can help us understand what's possible with the class. Let's try extending the exception class. Switch over to your editor. In the app folder, create a file called emptyArrayException.php. In the file, add the app namespace. Lastly, define the emptyArrayException class. It's common practice to add the word exception to your class name to help other developers identify a class for handling exceptions. The most important step is to extend the exception class. If we don't extend this class, our errors are not going to contain or behave like the other errors. We're going to leave the class empty. Let's just see what happens when we throw our error. Switch over to the utility class. Inside the conditional statement, we're throwing the error. Let's replace the current exception with the emptyArrayException class. Be sure to remove the / character. Our custom exception exists in the same namespace as the app class. There's no need to move it out of the global namespace. After making those changes, we can preview the error. It's the same as before. This time, the error is in using our class noted in the error message. We can take things further by outsourcing the message to the class. Every time we throw our custom exception, we must provide a message. What if we had to throw this exception in dozens of locations? Copying and pasting the same message would be a waste of time. In addition, it's possible for a typo to appear. Resolving this issue is simple. Let's grab the value passed into the instance. Next, switch back to the custom class. In the class, create a protected property called message. Its value will be the string we copied earlier. It's important to set the message property to protected. It's the modifier assigned to the original property. After making those changes, you can refresh the page to view the same message. This time, the class is responsible for setting the value. We don't have to pass in the value to set the message. That's the benefit of using custom exception classes. Another reason is to customize the error handling experience by catching this specific exception. In the lecture, let's talk about catching exceptions to customize the error handling. In this lecture, we're going to finally discuss how to catch exceptions. So far, we've been letting PHP throw exceptions or throwing exceptions ourselves. By throwing exceptions, we're allowed to intercept the error and handle the output. If we don't catch errors, PHP catches any uncaught errors by outputting the error message. In addition, it'll stop the script from running. Let me show you an example. In your editor, open the index.php file. In this file, we're calling the printArray method with an empty array. As a result, we'll receive an error. After this method, let's echo the following message: finished running script. In the preview, the message never appears because PHP stops the script from running once an error has been thrown. This behavior can be useful for development, but it's not something we may always want. Sometimes, you may want to redirect the user to another page. Other times, you may want to render the message from within a neatly formatted page. Catching errors is totally possible with the try-catch block. Surround the printArray method with a try block. The try block instructs PHP to execute the code written inside the block. If the code produces an error, the error is caught before PHP has a chance to handle it. The question is, how do we handle the error? After the closing curly bracket, add a block called catch. The catch keyword can be used for executing code when an error gets produced from the try block. If an error isn't thrown, the code inside this block is never executed. After the catch keyword, add a pair of parentheses. In these parentheses, we can accept the error that was thrown by our code. Let's add a parameter called e with the empty array exception class. Before we forget, let's import this class from the use statement. So, the catch block can be used for catching errors. However, we can filter the types of errors it can handle by specifying the type in the parentheses. PHP will notice that this catch block only handles the empty array exception. What if our code throws a different exception? The code inside never gets executed. PHP falls back to its original exception handler. Before we go further, let's try echoing a message from the catch block. I'll write the following message. Custom exception, get message break element. The e variable stores the instance created by our class. Our class doesn't have a getMessage method defined inside it. However, it inherits the exception class, which does have this method. If we look at the preview, the message from our catch block gets executed. In addition, the echo statement after the try catch blocks gets outputted as well. We don't have to worry about errors from disrupting the flow of our application. We can take things a step further by handling multiple exceptions. As noted earlier, the catch block we've written only handles our custom exception. However, as we know, it's possible for multiple exceptions to be thrown. After the catch block, we can chain another catch block. In the parameter list, add the e parameter with the exception class. Here's where things become interesting. As we know, all errors are derived from the exception class. Since that's the case, any exception not handled by previous catch blocks will be handled by this catch block. In this block of code, echo the following message. Default exception, getMessage break element. This is how we can catch all errors without allowing PHP an opportunity to do so. But what if we want to catch multiple errors and run the same block of code? For example, previously, we were using the invalid argument exception class to throw errors. We can apply multiple exceptions by separating types with the pipe character. Let's chain the invalid argument exception class. This block of code is guaranteed to run if the error is an empty array exception or invalid argument exception. There's one last feature worth mentioning. It's completely optional to add a finally block to our try catch blocks. Let's add it to our example. The finally block can be tacked on to execute additional code after the code from the try block gets executed. If an error gets thrown, PHP will execute the code inside the finally block regardless of what happens. You can use this feature to always execute code. Let's try echoing the following message. Finally block break element. In the preview, the message from the finally block appears. That's about it for catching errors. You don't always have to handle errors, but if you need to, you should always use try-catch statements. In the next lecture, let's explore another class from PHP. In this lecture, we're going to explore a popular class for working with dates called datetime. Check out the resource section of this lecture for a link to the documentation page for this class. If you scroll through the page, you're going to find a lot of methods for interacting with the date. We can perform actions from setting the time zone to finding the differences between two dates. Before we jump into this class, there's a set of functions that I want to mention. PHP offers two functions called date and time. I'll provide links to both functions in the resource section of this lecture. These functions can be used for working with dates in PHP. Despite that, the datetime class is more powerful than its function counterparts. If you just need to output the date, these functions can be simpler to work with. However, if you need features for working with time zones, you're better off with the date-time class. In my opinion, dedicating time to learning the date-time class is a worthwhile investment. So, let's get started. Switch over to your editor. Below the imports, I'm going to remove the current code. We don't need it around for this example. Next, let's create a variable called date. Its value will be a new instance of the date-time class. Afterward, let's dump the contents of the date variable surrounded by a pre-formatted tag. You'll notice I'm not using the printArray method from the utility class. This is because the method we've created only accepts arrays. The date variable contains an object, which is not compatible with our method. If you would like, you can create a utility static method for neatly printing objects. I'll leave that to you as a mini exercise. In the preview, our object was successfully created. There's a property called date, which contains the current date. You may get a different value depending on when you're watching this video. By default, new instances of the date-time class store the current date and time. If you were to refresh the page, the time is slowly updated. That's great, but what if you want to use an older date? Let's look at the documentation page for the date-time class. On this page, search for the construct method definition. The documentation doesn't provide information on a single page for a class. Instead, we must be willing to click the various links to find the information we're looking for. The best place to start is with the construct method. As you can see, the constructor accepts the date and time zone. However, we may want more information. Luckily, we can click on the method for better descriptions. Let's click on the construct method. Just like that, we're taken to a page with more info related to the construct method of the date-time class. Scroll to the parameters section. According to the description for the date parameter, we must use a valid date-time format. Once again, we have to click on a link for more info. This time, we're taken to a page with more information on how dates can be formatted. For information with examples, we have to click on the Date Formats link. Finally, we'll arrive at a page with examples of values we can pass in. For example, we can pass in a date in an American format, which is the month, day, and year. Let's copy one of the examples. Next, paste it into the date-time class. In the preview, the date was successfully stored. Now there's one thing worth noticing. The time has been set to midnight. By default, if we don't provide a time, PHP assumes the time is midnight. Let's try setting the time zone. By default, PHP uses the UTC time zone. If you're interested in changing the time zone, you can do so through the second parameter. To save time, the second parameter must be an instance of the date time zone class. You can refer to the documentation for this information. Above the date variable, create another variable called time zone. Its value will be a new instance of the date time zone class. The time zone class accepts the name of the time zone to use. In the resource section of this lecture, I provide a link to a complete list of supported time zones. You can click on a continent to view the list of time zones. I already know what time zone I want to use. Back in the editor, pass in the America/Chicago. Afterward, pass in the time zone variable to the date time class. According to the preview, the time zone has been correctly set. However, the date has not changed. This is because PHP assumes the date and time have already been adjusted for the time zone. Now, you may be thinking, how do we change the date to a different time zone? We can chain a method called setTimeZone to the date variable. This method accepts a new instance of the dateTimeZone class. Let's pass that in with the following time zone, Europe/Paris. After making those changes, the time zone gets updated. More importantly, the time has been adjusted from midnight to a few hours ahead. We're not limited to changing the time zone. We can adjust the date or time independently. After the setTimeZone method, we can chain a method called setDate. This method can configure the date. It has 3 arguments, which are the year, month, and date to use. I'll pass in 2023 6/15. Next, let's change the time by chaining the setTime method. This method accepts the hour and minutes. I'll set the time to 9:30. Looking at the output, the date and time were changed. Awesome. Now you may be wondering, how do I know that I can chain these methods? To answer that question, we must go back to the date-time class documentation page. In the class definition, search for the setTimeZone method. If you were to look at the setTimeZone, setTime, or setDate methods, you would notice one thing in common. Each method has a return value of dateTime. Anytime a method returns the same class, you can assume that the documentation is saying that the method returns the current instance. As we know, returning the same instance allows us to chain methods. This is how I know that I can chain each method one after the other. Let's head back to our project. We've been rendering the entire dateTime object. However, you're likely to just output the date. We can output the date by running a method called format. The format method returns a string version of our date. It has one argument, which is a format for the date. We can learn more about this argument by checking out the documentation. In the dateTime class, open the documentation page for the format method. If we scroll to the parameters section, the format parameter contains a table of possible values we can pass in. PHP uses a placeholder system for formatting the date. If we write a specific placeholder, the placeholder gets replaced with a specific piece of the date. For example, writing the letter D is a placeholder for the day of the month with leading zeros. You can look through the table for the various placeholders. I already know what format I'll be using. Back in the editor, I'll pass in the following: F, J, Y. The format is case sensitive, so if you're using the same format, make sure that your letters match my casing. These placeholders display the month, day, and year. If we look at the preview, that's exactly what we get. There's one more thing I want to show you. Currently, we're working with dates in American format. If you live in Europe, you may prefer the European format. To demonstrate this issue, I'm going to remove the modifications we made to the date. Next, I'll change the date to 04/10/2022. The American format for dates is the month, followed by the day and year. Europe's format is the day, followed by the month and year. Essentially, the month and days are swapped. If we look at the output, the date is April 10th, 2022. That matches the American format. If we were to read this date from a European perspective, the date would be October 4th, 2022. So, how can we get PHP to interpret this date differently? If we use slashes in a date, the date is interpreted as American. We can swap the slash characters with either dots or dashes. I'll switch them to dots. After doing so, the date has officially been interpreted as October 4th, 2022. It's a weird behavior, but something you should know just in case. There's a lot more we can discuss on the dateTime class, but it would take an hour or two to go over every feature this class offers. So, I encourage you to read the documentation to learn more. Alright, there's one more thing I want to mention. In the resource section of this lecture, I provide a link to a library called Carbon. Carbon is a popular third-party solution for working with dates in PHP. If you plan on learning Laravel, which is the most popular PHP framework, it uses the Carbon package for working with dates. Even if you're not using Laravel, Carbon is a popular solution among the PHP community. I highly recommend it for a more robust date system. So, you're probably sitting there wondering, why did I spend so much time on the dateTime class? Well, let's read the description of this package together. The Carbon class is inherited from the PHP dateTime class. Below the description, the The carbon class is extending the date-time class. Therefore, it's safe to assume that anything you can do with the date-time class can be done with the carbon class. It's just a class built on top of PHP's existing class. With that being said, the carbon class is not part of the PHP language. It's a completely independent package that must be downloaded separately. In a future section, we're going to learn how we can download official packages from the community. I wanted to mention this library, as you'll most likely see it in other projects. That's all I wanted to say for now. In the next lecture, let's explore other classes offered by PHP. In this lecture, we're going to learn how to loop through objects with the for each loop. The goal will be to create an object that displays the days in the current week. First, let's create a class. In the app folder, create a file called currentweek.php. Add the app namespace. Next, define the current week class. In this class, let's create a public property called date with the date-time class as the type. We'll be using this property to store the current date. Next, let's create an integer property called daysFrom with an initial value of 0. This property will store the number of days from the current week. I know it doesn't make sense now, but you'll see how it'll help us in a moment. Next, let's initialize a value for the date property. Currently, it's not possible to initialize the property from the class level. We must do so from the construct method. Define that method in our class. Next, set the thisDate property to a new instance of the datetime class. Overall, we have a class that stores the current date. Before we start adding additional functionality, let's see what happens when we loop through an object. Open the index.php file. Inside the import statement, add the current week class to the list. Next, replace the code below the import statement with a new instance of the current week class. Store the instance in a variable called current week. Lastly, let's create a for each loop. The expression will be the following: current week as value. Afterward, let's dump the value variable. Lastly, echo a break element to make it easier to read the contents of the value variable. If we look at the preview, the properties have been dumped. By default, PHP allows developers to loop through an object's properties. The for each loop is not limited to looping through arrays. However, there is one limitation of this feature. Only public properties are supported. For example, let's head back to the class. Instead of using the public modifier, change the properties to private. In the preview, nothing appears. This is because we can't access private or protected properties. Be aware of this behavior when looping through properties. Let's shift our focus back to our original goal. The goal is to display the dates in the current week. To accomplish this goal, we must implement an interface called iterator. Throughout the course, I've said the word iterate. I never took the time to explain what that exactly means. Let's quickly demystify this terminology. Firstly, the word iterate describes the action of repeating something over and over again. By using a for each, for, while, or do while loop, we're performing iteration. The second word to know is iterable. A value that is iterable means that it can be iterated. As we know, arrays are considered to be iterable since we can loop through them. Objects can be used in loops too. There's an interface called iterator defined by PHP. If we implement this interface, PHP gives us the power of controlling how an object is iterated. In the resource section of this lecture, I provide a link to this interface. I recommend checking it out for more information. Let's try using it in our class. Back in the class, implement the iterator interface. After adding this interface, our class must define 5 methods. Let's go through each of them. Below the constructor function, define a method called current. Our application has strict typing. Therefore, we must set the return type of our function to match the return type of the interface. If you were to look at the documentation, the return type is mixed. So, this function gets called on each iteration of a loop. If we're looping through an instance of the current week class, as we are in our index.php file, this function gets executed for each iteration. From this function, we must return a value. Since the return type is mixed, we're allowed to return any type of value. Whatever is returned will be the value stored in the value variable from our loop. For this example, let's return the date formatted for output. Return the following. This date format FJY. You're already familiar with this format from the previous lecture. It'll return the month, day, and year. Our current function is ready. The next function we must define is the key function. The return type of this function must be mixed, as indicated from the interface definition. Arrays can have keys. The purpose of keys is being able to identify a specific value. Each value returned by the current function must have a key associated with it. Luckily, we have a property called daysFrom, which counts the number of days from the current date. Let's return this property from the function. Currently, our loop never uses the key, so we won't be able to verify the value unless we update the loop. Switch back to the index.php file. In the loop, add the key variable before the expression. Next, let's add the key variable to the variable dump function. Before we can test our code, we have 3 remaining functions left. Back in the class, define a public function called next. Set the return type to void. This function gets called after the loop finishes running on a single iteration, thus giving us an opportunity to change the value that will be returned by the current function with a different value. In this case, we're interested in getting the next day. If you were to look through the dateTime class, there's a function for modifying the date called modify. Let's call it from the date property. This method accepts a date and time format. It's the same kind of format you would pass into a new instance. The question is, how do we get the next day? Let's refer to the documentation of the date and time formats. If you lost that page, don't worry. I provide a link to it in the resource section of this lecture. From the table of contents, we click on the relative formats link. Here's where things get surprising. We're not limited to just passing in dates. PHP accepts day-based notations like tomorrow or yesterday. By passing in a string that says yesterday, PHP will be able to accurately grab the day before today. Looking through the list, there's a notation for tomorrow. Let's use it for our class. Back in the editor, pass in tomorrow into the modify method. This should update the day to the next day. After updating the date, let's increment the daysFrom property with the increment operator. The fourth function we should define is called rewind. Add it to the class. Set the return type to void. The rewind function gets called when a loop is initiated. It's recommended to use this opportunity to reset the values from within our class. In the next function, we're changing the date. If we're restarting the loop should start from today, not 7 days from now. Let's call the modify function again. This time, pass in today to get today's date. Technically, we could have set the property to a new instance of the dateTime class. The result would have been the same. However, I prefer to just modify the date, since creating an instance may take longer. In addition to resetting the date, let's reset the daysFrom property to 0. We're almost finished. The last function that must be implemented is called valid. Add it to the class. Set the return data type to Boolean. PHP doesn't know how many times the loop should run. It calls this function after an iteration has been completed. To be more specific, it gets called after the next and rewind functions have been called. You can safely assume you're working with the latest values in your class. This function must return a Boolean. If true is returned, PHP moves on to the next iteration. Otherwise, the entire loop is stopped. In our case, we're interested in displaying the days in the current week. In total, our loop should run 7 times. Let's return the following. This days from less than 7. If the days from property reaches 7 or higher, the loop will stop running. That should do it. We've successfully implemented the interface. In the preview, you should be able to refresh the page. A list of dates appears ranging from today to 7 days from now. You may get different dates based on when you're taking this lecture. However, if you get the next 7 days, you can consider your solution a success. There's one more thing I want to show you before concluding the lecture. PHP has a new data type that we can use to accept objects that can be iterated. For example, switch over to the index file. Above the loop, define a function called foo. Next, move the loop inside the function. Inside the parameter list, let's add a parameter called iterable. Rather than looping through a specific object or array, we'll accept the value as an argument. Therefore, let's change the expression inside the for each loop to use the iterable parameter instead of the current week variable. Lastly, let's call the foo function with the current week variable. After making those changes, our script is working as before. That's great, but there's one glaring problem. The iterable parameter does not have type hinting. One solution would be to use the current week class. That works, but it limits our function to instances of this class. What if we want to accept arrays or objects that implement the iterator interface? In these cases, we can use a data type called iterable. The iterable data type can be applied to parameters that accept arrays or objects that implement the iterator interface. Looking at the preview, our script continues to work. That's great. This is a data type you should be aware of if you plan on using the iterator interface. Alright, that does it for now. Let's continue exploring PHP in the next lecture. In this section, I've got 2 exercises for you to try out. If you're aching to get started, jump straight into the next lecture. For those of you who want a little more info, this lecture is for you. As always, I provide hints and the solution in the tabs. For those of you watching the free preview on YouTube, you'll find the same information from the gist. To be completely honest, I don't have much to say about the nucleotide count exercise. As long as you read the description and follow the directions, I think you should be able to figure out a solution. Similar to the previous exercises, this solution requires functions that we haven't gone over. It'll be your job to read the documentation for those functions to implement a solution. Let's shift our focus to the grade school exercise. For this exercise, I've decided to provide a hint that makes you Google an answer. However, this time, I'm not going to tell you to Google a function. Instead, you will search for an operator. I haven't discussed every operator offered by PHP. I've only discussed the most popular operators. Every now and then, you're going to come across an operator that you don't recognize. A good way to learn about an operator is to research it online. With that being said, use the nullish coalescing operator is not the only way to solve this exercise. If you would like, you can use a conditional statement. It's just as effective. However, if you want to write shorter code, this operator can be useful. It's up to you at the end of the day. That's all I have to say about these exercises. As always, I will provide a video that walks through the solution. I wish you the best of luck. In this lecture, we're going to solve the nucleotide count exercise. The description for this exercise explains the sequence of DNA. The goal of this exercise is to create a static method that accepts a DNA sequence. The method should count the nucleotides in a DNA sequence. In total, there are 4 types of nucleotides, which makes things easier. Our method should count the A, C, G, and T characters in a given string. First things first, we must update our method to be a static method as mentioned in the description. Otherwise, our test won't work. After the public keyword, add the static keyword. Next, we can start counting the characters in the string. The method accepts the DNA sequence as a string. In addition, a return value is an array. We're going to store the occurrences of a specific nucleotide as an item in the array. Inside the method, let's return an array with the nucleotides as keys. We're using an associative array since we need to store the nucleotide and the count. The nucleotide will be the key, and the count will be the value. The last step is to count the characters. Luckily, PHP has a function for this specific action. For example, let's set the A nucleotide to a function called substring_count. This function searches a given string for a specific group of characters. It'll return the occurrences of that group of characters as a result, which is exactly what we want. There are 2 arguments. Firstly, we must provide the string to perform a search on. Pass in the input parameter. Next, we must provide the group of characters to search for. In our case, we're just interested in searching for the A character. That's it. The rest of the items are the same. I'm going to call this function for each nucleotide and update the second argument to the respective key. Let's try running our tests. Great, we've successfully passed the test. Hopefully, you are able to understand how I completed the challenge. Let's dive into the next challenge. I'll see you there. In this lecture, we're going to start working on the grade school challenge. The goal of this challenge is to develop a system for storing a list of students in a school. To be more precise, this system should be able to do 3 things. I've listed them out in the description. Firstly, the system should be able to add a new student to a specific grade. Secondly, the system should be able to return a list of students in a given grade. Lastly, it should be able to return a complete roster of students from all grades. Most importantly, this feature must return them with the grades and students in ascending order. I've provided you with a basic class with the methods for each of these actions. Let's begin writing the logic. Our first step is to create a property. Since the list of students must be accessible in all methods, it makes sense to store this information from a property. At the top of the class, create a private property called students. Set the value to an empty array. Next, let's begin implementing the add method. We're given 2 pieces of information, which are the name of the student and their grade. As mentioned in the description, multiple students can be added to the same grade. Therefore, the grade should be an array itself. In this case, we can use a multi-dimensional array, which is another way of storing an array from within an array. Type the following: this student's grade empty brackets equals name. In the array, we're adding a key for the grade. The value for this key will be another array. As we know, using an empty pair of square brackets adds an item to an array. In this case, the inner array will contain the name of the students. That's it for the first method. We can move on to the second method. This method must return an array of students for a specific grade. We're given the grade as an argument. Returning a specific list of students is as simple as returning the this student's grade property. However, there's one problem with this solution. What if the grade doesn't exist? If the grade doesn't exist, there is no list of students to return. That can cause issues since the return type is set to array. We must always return an array from this method, regardless if we can find a list of students. There are different ways of tackling this problem. The simplest way is to use the nullish coalescing operator. We haven't talked about this operator before. It's an operator that allows us to return a value if another value is empty. If you read the hints, I told you to search for this operator. From the articles, you should have been able to learn how to use it. Let's give it a try. Add the following: question mark, empty square brackets. The two question mark characters are known as the nullish coalescing operator. This operator checks the value on the left for a value. If the value is null or undefined, we can return a different value by specifying it on the right. So, if the grade doesn't exist, we'll return an empty array. As a result, our method always returns an array. Our second method is finished. The last step is to implement the students by grade alphabetical method. As mentioned in the description, this method must return the complete list of students from all grades. On top of returning a complete list of students, the grades must be sorted in ascending order. Students from each grade should also be sorted in alphabetical order. Therefore, we must perform sorting multiple times. The first part is easy. Inside the function, call the ksort function with the thisStudents property. The ksort function sorts an array by using its keys. In the add method, we're storing the grade as the key, so it makes sense to use this function to sort the array of students. That takes care of the first half of the problem. The second part of the problem is sorting in each grade. Unfortunately, PHP doesn't have a single function for sorting nested arrays. If we want to sort each grade, we must perform a loop. Let's return the array map function. We're not attempting to return the original array of students. Instead, we're trying to return a modified version of it, hence why we're using the array map function. This function has two arguments, which is an anonymous function and an array to loop through. Let's pass in an anonymous function. For the second argument, pass in the thisStudents property. In the function, we're given each grade as an argument. Let's accept the argument as grade. This parameter will contain the students for each grade. Since the grade parameter is just another array, we can call the sort function to sort the students by alphabetical order. Lastly, our function must return the array so that it can be a part of the results. That's it. Let's try running the tests. All tests have passed. Our solution works as intended. Did you get a solution similar to mine? If not, that's fine. As long as the tests passed, you can consider your solution complete. That's all the challenges I have for now. Let's get back into learning PHP. In this section, it's time to start working on the master project. So far, we have focused our time on basic PHP concepts, but we haven't been able to apply our knowledge to a real project. Programming is so much more than learning syntax. Writing scalable code is a challenge of its own. Technically, you can start creating an application with the knowledge you've gained thus far. If you do so, you may come to realize the difficulties of writing scalable code. Oftentimes, beginners write unstructured, unmaintainable, and sloppy code. In the industry, we refer to this as spaghetti code. Writing spaghetti code should be avoided at all costs. For this reason, we're going to develop an application. To be more specific, we're going to be building an expense tracking application. It won't have all the bells and whistles of a modern expense tracking app. Regardless, it'll have enough features for us to explore the remaining concepts of PHP development. Here's what the final product looks like. There's a page for the dashboard, uploading transactions, and viewing receipts. Authentication and authorization are another set of features we'll be implementing. Believe it or not, we're going to be developing two projects from within a single project. What am I talking about? First, let's understand the idea of a framework. In the programming world, a framework is a set of tools and solutions for solving common problems. If you think about it, most applications have similar requirements: authentication, form validation, routing, and basic security protection are essential features. It would be inefficient to repeatedly write these features for every new project. To save time, frameworks were introduced into the ecosystem to rapidly build projects. Frameworks are meant to provide a basic foundation that can be built upon to develop a custom application. There are dozens of PHP frameworks available. Slim, Laravel, and Symfony are the most popular frameworks. Some frameworks are minimalistic, providing only the basic requirements for most projects. Other frameworks provide everything but the kitchen sink. So, which one are we going to be using? The answer is none of them. Instead, we're going to be writing a custom framework from scratch. Hence why I said we'd be developing two projects from within a single project. Writing a custom framework is a job of its own. Our project is going to have two components. Firstly, we're going to have code specific to our application. This code is going to be tightly coupled to our project. If we were to move this code into a completely separate project, it wouldn't work without making major adjustments. Secondly, we're going to have code specific to our framework. Unlike our application code, this code will be portable and flexible. Theoretically speaking, our code should be transferable from project to project. We should also be able to build on top of it to develop a custom application. Compatibility with various project requirements is critical. But why? Why should we write a custom framework when other frameworks are available? More often than not, my projects are written with popular frameworks. I have never used a custom framework for any project. Frameworks are awesome. They boost productivity and provide standards for teams. While frameworks are great, beginners rely on them too heavily. As a beginner, your number one priority should be learning to program, not learning a framework. Developing a custom framework is a great way to learn how to program. When you eventually move on to a framework, you'll be able to understand what's going on under the hood. With that being said, the framework we're developing is not meant for production. It's purely for educational purposes. If you were to compare our code with other frameworks, you'll notice that it's missing a lot of features. So, please don't use this framework in a real project for clients. You're better off with a battle-tested framework developed by the PHP community. Some of you may be curious as to if this project can be added to your resume. The answer is absolutely. Getting a job as a PHP developer requires a resume. On your resume, you should have projects to showcase to recruiters to prove you know how to build an app. I'm sure this project would look great on any resume. After finishing the course, I highly recommend adding new features or changing the appearance of the app. There may be other developers who have the same project. Standing out is very important during the interview process. Alright, let's get into developing the project. Once you're ready to get started, I'll see you in the next lecture. In this lecture, let's take a moment to talk about text editors. Please don't skip this section as I talk about important configuration settings for PHP. Thus far, we've been using Replit. It's been great for learning PHP, but we're going to need something more flexible. I think it's time we start working on an environment installed on our machines. The first thing we'll need is a text editor. There are dozens of programs available for writing code. The most popular solutions are Visual Studio Code and PHP Storm. Links to both programs can be found in the resource section of this lecture. Both programs are great for PHP development. Visual Studio Code is completely free. Best of all, it's extensible. The community constantly creates extensions for tailoring the editing experience. It's an editor compatible with dozens of languages outside of PHP. As for PHP Storm, it's a premium editor. Truthfully, you're going to find more PHP features in this editor than Visual Studio Code. However, for our purposes, Visual Studio Code will suffice. If you want to use PHP Storm, that's fine. I'll be using Visual Studio Code since it's free. Here's what I want you to do. Download and install Visual Studio Code. Installing this editor is like installing any other program. Just keep clicking Next until you've reached the end of the installation. I'm going to quickly do so on my machine. Welcome back. I've got Visual Studio Code up and running on my machine. The next step is to configure our editors with extensions. Out of the box, Visual Studio Code has minimal support for PHP. If we want the best PHP experience possible, let's grab an extension from the community. On the left side of the editor, there's a button called Extensions. Click on it. Next, search for an extension called PHP IntelliFence. This extension was created by a user called Ben Mewburn. Make sure you found the correct extension. Over 8 million developers are using it for PHP development, including me. After finding it, click the Install button. We're not finished yet. This extension can conflict with Visual Studio Code's support for PHP. Therefore, disabling Visual Studio Code's PHP features is crucial for a smoother developer experience. Luckily, Visual Studio Code is a modular editor. We have complete freedom over disabling some of its features. In the search bar of the Extensions tab, search for the following: @built-in PHP. Two extensions will pop up called PHP Language Basics and PHP Language Features. Click and disable the Language Feature extension. The other extension can remain enabled. That's it. We're ready to start writing PHP. I've got one more optional step you can take. Visual Studio Code's appearance can be modified with themes. Themes are a feature for changing the color and font of the editor. They don't affect the actual code we write. It's purely aesthetics. In the search bar, click on the filter icon. Under this icon, select the Category Themes option. From these search results, you'll be able to find various themes available. As an exercise, try finding a theme suiting your style. There's no wrong answer. Personalizing your editor can make the learning journey more enjoyable. For this course, I'll be using a theme called Shades of Purple. It's a personal favorite. Once again, it doesn't affect the actual code itself. It only changes the color. If you have found a theme that suits you, I'll see you in the next lecture. In this lecture, we're going to discuss the LAMP stack. It's one of the most popular stacks for PHP development. So, what is the LAMP stack? Why is it so popular? To begin this discussion, I want to recap the idea of an environment. Environments are the physical location where your application is hosted with the necessary software installed and configured to execute your program's code. Without the proper software, your programs remain unfunctional. Oftentimes, you're going to hear developers refer to their environments as a stack. The words stack and environment can be interchangeable terms at times. However, there is a difference. The stack refers to a list of software for executing your application. It doesn't refer to the actual location of where your program is running. I'm getting a little ahead here, but you should know that it's possible to run an application on multiple systems. This is known as horizontal scaling. If you're in the early stages of developing an application, a single server will suffice. On the other hand, multiple servers may be required for running an application. Let's say you're Microsoft or Amazon. There isn't a single server alive capable of handling the traffic required by these companies. It's likely for corporations to have multiple servers. On each server, the same software or stack may be installed. There are different stacks available. Developers have their preferences over what stack should be used for developing an application. In the PHP world, there are two popular stacks called LAMP or LEMP. These are acronyms, which contain the list of software for running a PHP application. LAMP stands for Linux, Apache, MySQL, and PHP. The LEMP stack is the same as the LAMP stack, with the exception of Nginx over Apache. Lastly, for databases, you can use MySQL or MariaDB. Let me go through each of these programs. First and foremost is the operating system. The most popular operating system for PHP environments is Linux. According to recent statistics, 80% of production environments are Linux. The other 20% is Windows. Up next, we need a web server. The job of a web server is to handle requests and responses. If the user asks for an image, the server should send the user an image. If they ask for a CSS file, the server should respond with a CSS file. So on and so forth. One of the most popular web servers available is called Apache HTTP Server. It's free and open source, just like PHP. There's an alternative program among the PHP community called Nginx. Developers who use Nginx over Apache refer to their stack as LEMP instead of LAMP. Based on statistics, Both web servers are equally popular. You can't go wrong with either option. For this course, we're going to be using Apache. It's easier to install and configure. Up next, we have the database. There are two popular options, which are MySQL and MariaDB. MySQL is considered the more mainstream option. Over the past decade, developers have been slowly switching to MariaDB. There's been controversy over MySQL because it's owned by Oracle. MariaDB is a fork of MySQL. Forking is the terminology to describe a program that's a copy of another program taken in another direction. The original maintainers of MySQL created MariaDB to keep the project open source and community driven. Regardless of where you stand, both databases have a lot of compatible features. It's completely possible to switch from one database to another. For this course, we're going to be using MariaDB. Last but not least, PHP is part of the stack too. We must always have PHP installed in order for our app to work. In the resource section of this lecture, I provide links to various programs for installing the LAMP stack on our machines. If you're like me, you're probably not using Linux. Not to worry, the PHP community has curated solutions for easily installing the LAMP stack on Windows and Mac machines. You can use XAMPP, MAMP, WAMP, or Laravel. For this course, I highly recommend using XAMPP. The X in XAMPP stands for cross-platform. XAMPP is compatible with Windows and Mac. Another programming language called Perl is available with this stack. XAMPP is over 2 decades old. For a long time, Perl was considered to be a standard programming language for servers. This is why it's part of XAMPP. This course does not use Perl, so you don't have to worry about learning another language. Before moving on to the next lecture, I want you to download and install XAMPP on your machine. Installing XAMPP is like installing any other program. Just keep clicking Next until you've reached the end. With that being said, you may prefer another program like WAMP or MAMP. If that's the case, you will be expected to debug your own environment. Since there are so many environments with their own way of doing things, I can't cover every solution for configuring environments. I will only be demonstrating the process of configuring files in XAMPP. Please be aware of that when using a different program. For the smoothest experience possible, I highly recommend using XAMPP over any other program. Alright, once you've got XAMPP installed, I'll see you in the next lecture. In this lecture, we're going to explore the control panel for XAMPP. It's going to be quick. Initially, you're going to be shown a list of modules, which refers to the list of software installed with XAMPP. The most important modules are Apache and MySQL. By default, all modules are turned off. We can turn on a module by clicking on the Start button next to the respective module. Let's turn on the Apache and MySQL modules. Turning on Apache enables the web server. As for MySQL, this program starts our database. I'll talk about them in a moment. What about the other modules? As we know, XAMPP allows developers to run a LAMP stack on their machines. So, why do we have these other modules? XAMPP bundles other software commonly used in web development. They're not a part of the official LAMP stack. Nevertheless, they're extremely useful tools. Let's go through them. FileZilla is an FTP server for transferring files. Sometimes you may need to transfer files from your system to your XAMPP project. For this course, we're not going to need file transferring features. Up next, we have a module called Mercury. A common feature in web applications is the ability to send emails. If you're working locally, you must have an email server installed on your machine. Mercury is a free solution for adding email capabilities to your server. Once again, it's not a feature we're going to need. Lastly, Tomcat is another web server, just like Apache. The main difference is that Tomcat supports Java. Java is another programming language. If you ever need support for Java, you may want to consider using Tomcat. That makes you wonder, where's PHP? Well, by turning on Apache, you're also enabling PHP. XAMPP has configured Apache to send PHP files to the PHP interpreter. We don't need to configure or install PHP ourselves. For the rest of this course, you should always have Apache and MySQL running unless I state otherwise. The last thing I want to show you is where to find the installation of XAMPP. To the right of the panel, there's a list of buttons. One of them is called Explorer. Click on it. Upon doing so, your File Explorer should open. You're going to find all the software and configuration bundled in a single directory. It's very important to know where to find these files. Throughout the course, we're going to be modifying the files in this directory as well as developing our project. Alright, that's a basic overview of XAMPP. In the next lecture, let's start configuring the programs installed with XAMPP. In this lecture, we're going to start setting up the master project for this course. The master project we're going to be building will be an expense tracker. From now until the end of the course, our PHP journey will revolve around developing this project. As we continue to build the project, you'll be able to understand what it takes to build a professional PHP application using modern techniques. The first step in our journey is to create a folder for our project. The question is, where? To answer that question, let's check out our site. Open the XAMPP control panel. Currently, I have the Apache and MySQL modules running. For the Apache module, click on the Admin button. A new tab in our browser should open, taking us to XAMPP's dashboard. If we look at the URL, the path to this site is localhost. Typically, websites are hosted on servers from around the world. For example, Google and Amazon offer hosting services for PHP applications. We can access our sites by typing the domain in the browser. After typing a URL, browsers send our request over the network to retrieve a web page. However, since we're working locally, we need to tell the browser that the site is hosted on the same machine. Localhost is the URL for sending requests to the same machine. This URL is not exclusive to PHP or Apache. Most languages and web servers use localhost. Once again, by installing XAMPP, Apache was configured to accept requests to the URL. So, we know that Apache is working. But where can we find these files? Head back to the control panel. From the panel, open the File Explorer. There are dozens of files and folders. The only directory we care about is the htdocs folder, which stands for Hypertext Documents. Apache has been configured itself to serve files from this directory. This is why we don't need to type the full system path to view these files. By default, XAMPP has provided default files for testing Apache. You do not need to keep any of these files around. It's safe to delete them. Next, let's create a folder called phpiggy. phpiggy is going to be the name of our app. Next, let's open this directory with Visual Studio Code. If you switch to the code editor, you will be able to point your editor to a specific directory by navigating to File, Open Folder. I'm going to quickly move into the phpiggy folder. Next, let's begin setting up the structure of our project. Throughout this course, we haven't really discussed how our project should be structured. Now that we're building a real project, it's time to carefully consider where files should live. Projects with dozens of files can be hard to manage without a proper structure. Among the PHP community, there isn't a standardized project structure. A lot of developers have their preferences. The structure I'm going to show you is common among some projects. You're free to manipulate the structure to what makes sense to you. Inside our project, create a folder called Public. The public folder is going to contain files accessible to the public. If you think about it, not every file should be accessed by users. Some files may contain sensitive information. Therefore, it's recommended to have a directory dedicated to publicly accessible files. In this folder, create a file called index.php. Next, add a hello world message inside our new file. For demonstration purposes, let's create a file called secret.php in the root directory of our project, so not inside the public folder. We're creating this file to test the ability to restrict access to files outside the public folder. Inside this file, type the following. This file contains a secret. Cool, let's try testing our work. Switch over to the browser. In the address bar, type the following: phpiggy/public. After doing so, we're able to view the contents of the index.php file. If we want to view files inside a nested directory, all we have to do is type the path relative to the htdocs folder. Interestingly, we aren't typing the name of the file in the URL. By default, Apache searches for a file called index.php when a file is not specified. While this works, we're still able to access the secret.php file. I'll remove the public path and access this file. This behavior is not what we want. Restricting access to files is common. If we want to restrict files, we must configure Apache. It's responsible for delivering files. In the next lecture, let's configure Apache for our project. In this lecture, we're going to briefly explore the configuration for Apache. Before we do so, let's examine two major issues with the current server. Currently, I'm able to access the index.php file inside the phpiggy/public directory. That's great and all, but it's not completely desirable. In real applications, the home page of a site is accessible via the root URL. It would be nice if we could type localhost without typing the rest of the directory. That's the first problem. The second problem is being able to access the secret.php file. Our site is vulnerable if users are able to access any file in our application. Both problems can be resolved with a feature called virtual hosts. Virtual hosts are a feature for creating multiple sites under a single server. By default, Apache can handle a single domain, which is localhost. Since we have a single domain, we're only able to have a single site. If you plan on using PHP for your career, you're likely going to work with multiple sites on your machine. One solution is to create a folder for each site and access that site via a folder. That can work, but it can be annoying to type out the entire folder to access a single site. Ideally, we should have custom domains pointing to our sites. That's what a virtual host is. We can create a custom domain in Apache. If we access a specific domain, files related to the domain are loaded. We can avoid accessing the wrong site. Creating a virtual host is possible by updating Apache's configuration. We can open the configuration in Apache with XAMPP. In the control panel, click on the config button for the Apache module. A list of files is going to be presented. We're interested in the httpd.configuration file. Click on this option. This file contains the configuration for Apache. Upon selecting this option, Notepad should open. If you know me, I don't like using Notepad to edit or write code. I prefer using Visual Studio Code. Luckily, finding the file is easy. Head back to the control panel. Under the configuration option, there's another option called Browse Apache. Click on it. Clicking this option opens the File Explorer pointing directly to our installation of Apache. The folder we're interested in is called Configuration. Taking a look inside this folder, we're going to find the httpd.configuration file. Here's what I want you to do. Use Visual Studio Code to open this file. You can do so by navigating to the File, Open File menu option. I'm going to quickly open this file. Here's what you should find. It's a file with hundreds of lines of code. This is probably your first time looking at a configuration file. Luckily, they're very easy to understand. I would argue that modifying a configuration file is simpler than learning PHP. All we have to learn are the syntax rules. Immediately, you're going to be greeted with comments. Comments are written with the hash character. The Apache team has taken the time to document most of the settings. However, there is a warning. Let's read it together. Do not simply read the instructions in here without understanding what they do. They're here only as hints or reminders. If you are unsure, consult the online docs. You have been warned. The links to the documentation can be found above this comment. I highly recommend checking them out if you're interested in understanding the entire configuration. For this lecture, we're only interested in adding support for virtual hosts. From this file, search for a comment that says Supplemental Configuration. You should be able to find it around line 500. Configuration files support the feature of importing additional configuration files. Similar to PHP, it can be overwhelming to have a single file for all your configuration. To keep files slim, you can split your configuration into separate files. A configuration file can be included with the include directive. Directives are similar to statements in PHP. They're lines of code for executing specific instructions. The only difference is they're referred to as directives instead of statements. The include directive loads an external configuration file. As you can see, Apache loads various files. The file we're interested in has a comment above it saying virtual host. While optional, we should configure our virtual host from this file instead of writing the configuration from this file. The path to the file is given to us after the include directive. Let's open it with Visual Studio Code. You can read the comments for more information on how to configure a virtual host. I'm going to quickly run by the instructions. If you scroll through the file, you're going to come across an example of a virtual host inside a pair of comments. The example can be found at the bottom of the file. Let's uncomment the virtual host tags. This syntax is referred to as a container. Whenever you use a directive, the directive gets applied to the entire server. However, you may want to apply settings to specific sites or folders. Apache allows developers to refine settings to specific locations by using containers. Containers have a similar syntax to HTML tags. It's the name of the container with a pair of angle brackets. Directives written inside the container will only apply to this virtual host. In the container, there are 5 directives. We only need the document root and server name directives. I'm going to uncomment them. The document root directive points the virtual host to a specific directory. This example already points to the htdocs directory. All we need to do is modify it to point to the phpiggy/public directory. Next, the server name directive accepts a custom domain. If we visit this domain, Apache can intercept the request. I'm going to use the following domain, phpiggy.local. You can use whatever domain you want. You can use example.com or myawesomesite.org. However, it's common practice to use the local domain extension. This domain extension is commonly used for identifying sites under development. Apache is ready to go. We're not finished yet. We've only configured Apache, but not our machines. Apache won't be able to receive the request until we've told our machine to send the request to it. To understand the problem, let's restart the web server. In the control panel, shut down and restart the Apache module. You must always restart Apache whenever you update the configuration file. Otherwise, changes won't take effect. Next, let's head over to our browser. In the address bar, try accessing our site via the http://phpiggy.local domain. Make sure you're using HTTP and not HTTPS. In a future lecture, we'll definitely look at how to generate a security certificate for HTTPS. For now, we're going to keep our site unsecured. Out of the box, XAMPP does not provide a security certificate. Therefore, we won't be able to use HTTPS. The browser won't be able to find the site. There's nothing wrong with Apache. Whenever we type localhost into the address bar, the browser knows to send the request to our machine. However, if we type in a different domain, the browser doesn't assume the site exists on the same machine. It searches the internet to find the site. Hopefully, this provides clarity to the problem. Our site is still on our machine, not on the internet. Therefore, we have to tell our machine that if we visit phpiggy.local, the request must be sent to our machine. We can do so by modifying the hosts file. Before browsers search the internet for the server that hosts the domain typed in the address bar, it'll look inside a hosts file. This file contains a list of domains and IPs. If our domain is listed in this file, the browser will send the request to the IP specified next to the domain. We can use this opportunity to send the request to our machine instead of over the internet. In the resource section of this lecture, I provide a link to a tutorial on how to find the hosts file. This file can be found on all operating systems, but it is in different locations. Scroll to the section that's relevant to your operating system. I'm using Windows, so I'm going to follow the instructions listed on this page. For Windows users, this tutorial includes instructions for grabbing an IP from a panel called hpanel. You can safely ignore these steps. Just skip to the part that says change the file manually. I'm going to follow these steps to open the host file. I'll see you in a moment. Alright, I've got the host file opened with Notepad. Your file may not look similar to mine. This is because I regularly modify the file for personal projects. Regardless, scroll to the bottom of the file. Add the following: #examp virtual hosts. Similar to configuration files, this file can have comments, which begin with the hash character. I always recommend adding comments for clarity. Below this comment, add the following: 127.0.0.1 phpiggy.local. Adding a host requires two pieces of information. Firstly, we must provide the domain of our site. In this case, it would be phpiggy.local. Next, we must tell our machine where to send this request, which must be an IP. The IP for localhost is 127.0.0.1. After making those changes, save the file. Next, head over to the browser and try visiting the phpiggy.local site again. This time, our site is working like before. Both problems from earlier are gone. Unlike the previous solution, we don't have to type the path to the folder. We have a simpler URL. In addition, the secret.php file is inaccessible via this URL. It's practically impossible to access this file from this domain. I know that was a lot to go through, but hopefully you got the gist of things. In the next lecture, let's look at configuring PHP. In this lecture, we're going to explore the PHP configuration from Xampp. There are different ways of viewing the configuration. The first option is to use a function. Before exploring this function, let's tidy up our project. We have a file called secret.php file. It isn't necessary to keep it around. Let's delete it. Great, we can move on to editing the index.php file. Previously, we were displaying a simple message. Let's replace the text with an opening PHP tag. After this tag, run a function called phpinfo. The phpinfo function is defined by the PHP language. This function generates a page with a complete list of settings for the current installation of PHP. Head on over to the browser to view the results. As you can see, our entire configuration is presented to us. This summary can be a great way to check out what's enabled on your system. But what about modifying the configuration? PHP provides us with two options for modifying the configuration. Firstly, we can use the official configuration file. Switch over to the control panel. Under the config button for the Apache module, there's going to be an option called php.ini. Click on it. PHP's configuration file opens with Notepad. Unlike Apache, PHP has a slightly different syntax. For comments, PHP uses semicolons. Once again, these comments can help you understand the various settings available. However, PHP has a dedicated documentation page for these settings. In the resource section of this lecture, I provide a link to this page. PHP allows you to configure various settings, from memory limits to disabling errors. It's impossible to go through every setting, but let's get a general idea of how we can configure PHP. As mentioned before, we can configure PHP through the configuration file. However, there's another solution, which is by using a PHP function. In this table, there's a column called Changeable. Not every setting can be modified with a function. This column indicates which settings are modifiable through PHP's function or the configuration file. If the column says PHP ini system or per directory, the setting can't be modified through a PHP script. You must do so through the official configuration file. As for everything else, you'll be able to alter the setting via a PHP script. Let's give it a try. Open the index.php file in your editor. Let's replace the PHP info function with an echo statement. We're going to echo a function called ini_get. The ini_get function returns a specific configuration setting. We must pass in the name as a string. Let's try grabbing a setting called memory limit. Every script has a limit as to how much memory can be consumed. If a script consumes too much memory, the script throws a fatal error. Let's try viewing the value in the browser. You may have a different memory limit than me. I have a limit of 512 megabytes. Let's head back to the editor. Before echoing the limit, let's try running a function called ini_set. This function gives us the option to override the current PHP configuration settings. You may be wondering, what are the differences between using this function over directly configuring the official configuration file? Modifications applied to the configuration file apply to all PHP scripts, whereas the ini_set function only affects the current script. This function has two arguments, which are the name of the setting and the value for the setting. Let's update the memory limit setting to 255 M. Next, head over to the browser. As you can see, the setting was modified. For this course, we won't need to change PHP settings, at least for now. The default settings are going to work for most projects. I decided to add this lecture so that you know how you can modify PHP settings. In this lecture, we're going to create an application class for our framework. As I stated in a previous lecture, the framework acts as a foundation for an application. Frameworks provide generic tools for solving common problems. Developers are expected to build on top of a framework. Therefore, I think it makes sense to start working on our framework. The question is, where do we begin with our framework? As a reminder, frameworks are a collection of tools. It's not a singular tool. Not all frameworks provide the same set of tools. For our framework, we're going to have 5 tools for routing, form validation, database interaction, compiling templates, and a container for injection. These tools should be separate from one another. If you're not familiar with these types of tools, that's perfectly fine. As we create these tools, I'll explain their purpose and intent. Our framework is going to be modular. If a developer wants to use routing without the other tools, they should be able to do so. Not every project is going to need a complete suite of tools. But what if a developer does need to use every tool? In that case, they would have to configure a framework's tools to work alongside each other. That's not ideal. A better solution would be to provide an additional class for managing the framework's tools. Rather than requiring developers to initialize each tool, the application class can handle most of the work. You can think of the application class as the glue for other tools related to the framework. I think it makes sense to create this class before developing any other tool. After all, the application we're building will utilize every tool in our framework. Let's get started. In our project, we're going to create a directory called source. Typically, there are 2 types of files you'll have in a project. Firstly, you'll have files containing code related to your application. Secondly, there are files for configuring the server. Ideally, these files should be separate from one another. The purpose of the source directory is to contain code related to our application's logic. Files for configuring the server should not be placed inside this directory. Inside this folder, create 2 folders called App and Framework. A few things worth noting about these directories. In most cases, the frameworks would not be bundled in the same directory as the application. Typically, they're shipped as packages that can be installed with a project. However, to save time, we're going to bundle the code under a single project. To keep things organized, we're going to separate our application code and framework code into separate directories. You'll notice the folder names are Pascal cased. Our application is going to be built with classes. This includes namespaces. It's standard practice for the folder names to reflect the namespace of our classes. The source or public directories won't directly contain classes. For this reason, Their names are all lowercase. After creating the directories, let's create the app.php file inside the framework directory. Once again, pay attention to the casing of my file names. As you can probably guess, this file is going to contain a class definition since the name is Pascal cased. Inside this file, let's enable strict typing with the declare statement. Next, add a namespace called framework. As you would expect, classes related to our framework are going to live under this namespace. After defining the namespace, define a class called app. Let's define a method to help us verify the application was initialized. Inside the class, define a public method called run. From within this method, echo the following message: application is running. Our class is ready. In the next lecture, let's use this class to bootstrap our application. In this lecture, we're going to bootstrap our application. To recap where we left off, we have a class called application for preparing the framework's tools. Since it's a class, we must create an instance of this class. The most logical location to perform this action is from within the index.php file. The file responsible for handling all requests is the public/index.php file. However, we're not going to create the instance from this file. Let me show you why. In the public directory, create a file called about.php. In this file, let's output a basic message. Let's pretend this file produces an about page. It's very likely that this page is going to rely on our framework. Since that's the case, this file is going to need an instance of the application class. Do you see the problem? For each page in our application, we must duplicate the code for instantiating the app class. Rather than duplicating code, let's outsource this logic into a separate file. In my opinion, the index file should be responsible for initializing the application. It should not be responsible for configuring our framework or preparing other files. The index file shouldn't have to worry about loading files. We should outsource this logic to a different file. Inside the source/app folder, create a file called bootstrap.php. We're creating this file from within the application folder because the code we're about to write will be specific to our application. You may have noticed, but the file name is not Pascal cased. As a reminder, it's common practice to use Pascal casing for files containing class definitions. In this case, you can safely assume files with lowercase names are not going to contain class definitions. It's a subtle but important distinction to make. Examining a file name can tell you a lot about the file's contents. A question you may have is, why am I calling it Bootstrap? The word Bootstrap is a term to describe a piece of code responsible for loading other files and configuring the project. I think it's an appropriate file name. Inside this file, let's enable strict typing. Moving forward, I'm always going to add strict typing to PHP files. I won't always mention it, but it's a step you should always take. Next, let's load the application file from the framework directory. Add an include statement with the following path: directory./framework.php. I'm using the directory constant to generate an absolute path. I always prefer to use absolute paths as opposed to relative paths for including files. Next, add the use statement to import the framework/app class. Afterward, create a variable called app. The value will be a new instance of the app class. Lastly, let's return the app variable. We're not calling the run method. The reason is simple. The job of this file is to load and configure the files necessary for our application. Starting the application should be the job of our files in the public directory. In the index file, let's load the bootstrap file with the following path: directory./source/bootstrap.php. This file returns data. Let's store this data in a variable called app. Now that we can access the application instance, call the run method to start the application. Let's test our work by switching over to the browser. Upon refreshing the page, the message from the run method appears in the document. Great! Our application is running smoothly. In the next set of lectures, we're going to improve our work by using auto-loading. In this lecture, we are going to get started with the command line. We'll be deviating away from our project for a few minutes. Our next goal is to set up auto-loading. Auto-loading is a feature for automatically including classes in our project whenever a class is referenced. This process can be performed without additional tooling. However, I think this is a great opportunity to introduce a tool called Composer. Before we can get into Composer, we must have knowledge of the command line. That'll be the focus of this lecture. The command line can be intimidating, especially if you're new to web development. However, it's going to be a necessary skill for PHP development. So far, we've used Replit and XAMPP to handle our environments. Both tools have provided UIs for initializing the server. Not every tool related to programming has a UI. The project we're working on is going to require these tools. In most cases, you're going to have to deal with the command line. This lecture will be an introduction to the command line. The command line is extremely powerful. There are dozens of commands available. Luckily, we don't need to be experts with the command line. Only a handful of commands will be explored. The other commands won't be relevant to us. Being a master of the command line is unnecessary for getting into PHP development. The commands we're going to learn will be all you'll need. Let's get started. The first step to using the command line is to open it. If you're on a Windows machine, search for a program called PowerShell. Linux and Mac users can find the command line by searching for a program called Terminal. I'm on a Windows machine, so I'll be using PowerShell. The command line is a window with white text against a dark background. PowerShell uses a blue background, but your operating system may use black. It's all the same. Before the existence of websites or interfaces, computer interactions were performed with the command line. Sending emails, opening files, or playing audio would be performed through the command line. You couldn't point and click like you can today. Developers prefer to use the command line for running programs. Interfaces can consume memory and CPU usage, whereas the command line does not massively affect the performance of your tools. As developers, we should aim to develop applications as quickly as possible. The command line is our best bet for rapid development. Initially, you will not be presented with walls of text. Normally, the command line points to a specific directory. In my case, I'm inside the user folder. You may be in a different location. In some cases, you may see a $sign symbol. This symbol separates the file path from your commands. If you're in a deeply nested directory, the command line may partially omit the path. The reason is to save space. It would be annoying to view the full path of a directory on every line. If you're unsure where you are, there's a command for the current location. Inside the command line, we can type pwd, which is short for present working directory. Upon entering this command, we are presented with the entire system path. If you're ever lost, this command can be helpful in giving you the current location. Now that we have an idea of where we are, let's move around. But where can we navigate to? Before you can navigate around, you have to know where you can navigate to. The next command on our list is called ls. This command is short for the word list. Enter this command. This command outputs a list of files and folders in the current directory. As you can see, the command line outputs the names of our files, their last modification time, and their permissions. Let's try moving into a directory. To move into a folder, we can run the cd command, which is short for change directory. After this command, we must provide the name of the directory to move into. For this example, I'll move into the music directory. Just like that, I'm inside the music directory. Moving into a directory is not our only option. We're allowed to move out of a directory. Inside the command line, let's run the cd command again. This time, we'll add 2 dots. 2 dots instruct the command to move up a directory. We are back to where we started. If I wanted to move through multiple directories, we could separate the paths with the slash character. For example, we can write the following, ... /../. This path moves me to the root directory of my drive. This behavior also applies to moving into directories. As an exercise, try moving back into the user's folder. It's okay to cheat. In the File Explorer, you can take a peek at the full path. With this knowledge, you can navigate to this directory with the cd and ls commands. Pause the video and give it a try. Welcome back. If you were able to move into the correct directory, that's great. If not, that's fine too. You can reopen the command line to set you back into the original location. To verify my location, I'm going to run the pwd command. The path should be the same path from the first time that we ran this command. That's basically it when it comes to commands. Honestly, there's not much to it. These commands will help you navigate around the command line. There are other commands that will help with modifying and deleting files, but you will not need them. We'll be working with an editor most of the time. If you have Visual Studio Code like me, you'll be able to open the command line by going to Terminal, New Terminal. One of the great things about this is that it automatically points to the current directory you're in. This behavior is a huge time saver. It won't be necessary to use the cd command to move into our project's directory. It's automatically pointing to this location. I'll be using this terminal throughout the rest of this course. If you don't have it, that's fine. You can continue using the command line your operating system has provided you. There's one more tip I want to mention. At the moment, the command line is located at the bottom of the editor. In my opinion, the interface feels cluttered. Luckily, we can click and drag the program's name from the top corner like so. As I drag the program, I'm going to attach it to the editor as a tab. It's easier to view the command line as an individual tab. For most of this course, I'm going to have the command line opened as a tab. In the next lecture, let's start using our knowledge of the command line to run a program called Composer. In this lecture, we're going to take the time to talk about PHP standards. The purpose of learning the command line was to use a tool called Composer. The reason we're going to use Composer is to help us with auto-loading code. But why use Composer? After all, we already know how to auto-load classes. To understand why, we must talk about PSR. PHP is a flexible language. We have a lot of liberty with formatting code. Take the following code snippet. There are two conditional statements. The first conditional statement has the opening curly bracket on the first line, whereas the second example has it on a different line. Both formattings are valid. This flexibility can potentially cause issues. If you're working on a code base with other developers, inconsistent formatting can lead to reading issues. We're only touching the tip of the iceberg. Designing classes is another concern when collaborating on projects. In the resource section of this lecture, I provide a link to a site called PHP Fig. A group of developers have decided to create standards for other developers to follow in their projects. By standardizing how code is written and formatted, projects become more consistent. These standards are highly popular. You can find them by clicking on the PSR link. PSR is short for PHP Standards Recommendations. You'll notice multiple standards immediately. Rather than having one large standard, the group has decided to split the standards for specific purposes. If you're working on a large project, you're likely to adopt multiple standards. For example, the PSR1 standard was introduced for basic formatting of classes. You can read through this page for guidelines and examples. You're already familiar with some of these rules. One example would be the names of our constants. All constants should be written with uppercase letters and underscore characters as separators. This is a guideline we've followed throughout the course. Let's head back to the list of standards. So, why am I talking about these standards? It turns out there's a standard for auto-loading. It's called PSR4. Let's click on this link. The PHP Fig team has created a standard for auto-loading classes. This document outlines rules for performing auto-loading. This standard is widely adopted by the PHP community. We should adopt it too for our project. There's just one problem. Writing the code to follow this standard takes time. Luckily, we don't have to. Composer automatically supports autoloading. Best of all, it adheres to the PSR4 standard. Rather than writing a custom solution, let's leverage Composer's feature to autoload our classes according to this standard. Once again, we don't have to use this standard. Despite that, PSR is considered to be the gold standard for most projects. There isn't a reason to use a custom solution when a solution by the community exists. In the next lecture, let's install Composer for auto-loading classes according to PSR4. In this lecture, we're going to install a tool called Composer. Composer is one of the most popular tools for managing dependencies. That leads us to the question, what is a dependency? Imagine we had two files called index.php and utility.php. In the utility file, we have a function called foo for echoing a message onto the page. As for the index file, we're including the utility file before calling the foo function. Without including the utility file, our script wouldn't work. We can consider the utility file a dependency. A dependency is a piece of additional code that is relied on by another program. Therefore, we have a dependency on our hands. Dependencies are common in most applications. Believe it or not, open source software is prevalent in the programming community. Developers love to share their work with others. In the resource section of this lecture, I provide a link to a site called Packagist. Packagist is the most popular repository for PHP packages. A PHP package refers to code written by another developer. These packages can be downloaded and included in our projects. Almost anything you need can be found here. For example, I'll search for a package to help me deal with currencies. As you can see, there are dozens of packages published by other developers to help us with currencies. I'm going to click on the first dependency called brick/money. The naming format for most packages is the name of the developer followed by the name of the package. A slash separates both names. On this package, you will be able to find documentation related to the current package. There's one section that I want to focus our attention on. Under the Requires and Requires Dev section, there's a list of dependencies for this package. I know that might sound strange, but it's not uncommon for packages to have dependencies of their own. Let's try clicking on the PHP unit dependency. We'll be taken to the dependencies documentation page. Just like before, this package has another set of dependencies. Therefore, if we want to use this package, we must download these packages as well as their dependencies if they have any. You can probably start to see a problem. Using a single package is not as easy as it seems. Most packages you'll use will have dependencies. Downloading multiple packages just to use a single package can be tedious. The problem compounds when you have to deal with versions. On the right side of the page, there's an official list of versions of this package. What if two packages require the same dependency but different versions? How would you resolve those differences or verify compatibility? For these reasons, a tool called Composer was introduced. In the resource section of this lecture, I provide a link to this tool. Composer is a dependency manager for PHP. It's capable of downloading a package along with its dependencies. If your dependencies have dependencies, those will be downloaded too. Best of all, Composer is capable of verifying that all packages are compatible with each other, saving you a lot of time in the process. In this course, we're going to be using Composer for two reasons. Firstly, we're going to be downloading packages from the community. Secondly, Composer can also load files from our project with autoloading. After all, if we think about it, our files are considered to be dependencies too. The first step is to install Composer. On this page, click on the Getting Started button. The installation process for Composer varies from system to system. If you're on Linux or Mac, follow the instructions from this section. For Windows users, you'll find the installation instructions right below. I'm on Windows, so I'll be following these instructions. Luckily, the installation process is simple. There's a downloadable executable file for setting up Composer. Download it onto your system. After doing so, run the program. After launching the installer, we're going to be asked a few questions. Firstly, we can install Composer in developer mode, which allows you to just install Composer. We're not going to use developer mode. Let's move on to the next step. Composer is going to ask us to point to where PHP is installed. Under the hood, Composer is written in PHP. As a result, PHP must be installed on our machines. Otherwise, we won't be able to use Composer. If you have XAMPP installed, you have PHP installed. All we have to do is select the executable file for PHP. I'm going to navigate to the XAMPP folder. Next, go inside the PHP folder, which is where PHP is installed. Lastly, select the php.exe file. We may be asked to update the path variable. I'm going to allow Composer to do so. After selecting that option, I'll proceed to the next step. I'm not going to configure a proxy. It won't be necessary for this installation of Composer. You should arrive at the final step of the process, which is a basic review of the installation details. Let's click Install. This process may take a while. Be patient as Composer is installed on your machine. After installation is complete, Composer gives us a warning. Composer does not work until we've closed all instances of the command line. If you have the command line or Visual Studio Code open, you may want to restart those programs. Lastly, you may need to restart your system for Composer to work. I'm going to open the command line in my editor. Before moving forward, we must verify Composer has been installed. We can do so by typing the following command: composer --version. The Composer command becomes available after installing Composer. This command allows us to install and manage the dependencies of our project. I'm introducing a new feature of the command line called a flag. Flags are written with dash characters before their name. The purpose of a flag is to modify the operation we're running. Normally, Composer installs dependencies. By adding the version flag, we're telling Composer to give us the currently installed version. If we run this command, the version of Composer gets outputted into the console, thus verifying Composer was installed successfully. You may get a different version based on when you're watching this video. Regardless, if the version appears on your screen, you're good to go. In this lecture, we're going to learn a new language called JSON. If you're already familiar with JSON, you can skip this lecture. I don't teach anything groundbreaking, just the basics will be covered. So, what is JSON? JSON is a format for reading and writing data. It's short for JavaScript Object Notation. As its name suggests, JSON was heavily inspired by JavaScript. However, you are not required to know JavaScript to learn JSON. There are plenty of developers who understand JSON without learning JavaScript. The reason is simple. JSON is considered incredibly easy to learn. Unlike other languages, JSON does not have features like functions, loops, or complex logic. That's not the purpose of using JSON. The main goal of JSON is to store data, plain and simple. Why would we want a language dedicated to storing data? That's a good question. There are various programming languages. Nowadays, developing an application with multiple programming languages is not uncommon. This poses a problem. What if we want to share data between languages? We need a format readable by each language. That's where JSON jumps into the picture. Almost all languages can read and write JSON. It's a convenient feature for simply storing configuration details for a project or tool. Like most languages, various data types are supported. We can store strings, numbers, booleans, arrays, and objects. The idea behind these data types is exactly the same as data types in PHP. The main difference is the syntax. Let's dive into the syntax of JSON. In the resource section of this lecture, I provide a link to a playground for JSON. This playground will help us validate our JSON code. To get started with JSON, we need to add a pair of curly brackets. Curly brackets in JSON represent an object. JSON files can only contain data. If you plan on inserting multiple pieces of data, you must use an object. Objects in JSON are similar to objects in PHP. We can have properties, but methods are unsupported. As mentioned before, JSON is a language for storing data, not logic. Properties follow a key-value format. Firstly, the key must be wrapped with double quotes. For our first key, let's try adding a property called name. Key-value pairs are separated with a colon. As for the value, our name can be considered a string. Just like PHP, strings are created with double quotes. Single quotes are not supported. If we used single quotes, the playground would throw an error. Always use double quotes. Let's add our name. Pretty simple, right? Let's keep playing around with the other data types. New values can be added by separating them with commas. Putting new values on new lines is recommended. Technically, you could write everything into a single line. However, your code may be difficult to read. Let's add a property called age. Numbers can be added as is. Our example is a whole number, but decimal values are supported too. Let's move on to booleans. The next example will be called is hungry with a value of true. Booleans can be true or false. Keep in mind, the property name must always be in double quotes. The data type does not impact the naming of the property. Secondly, spaces are not allowed. We are restricted to alphanumeric characters and underscores. There are two more data types. The next data type is an array. Arrays allow us to store a collection of values within a single property. Let's add an array called hobbies. Arrays are created with square brackets. Inside these brackets, we can add a series of values separated by a comma. I'm going to add some hobbies. The final data type is an object. Let's look at an example by adding a property called job. The syntax for creating an object is a pair of curly brackets. Inside the object, I'll add a key called company. The value will be Udemy. Just like that, we've created our first JSON file. There's not much else to say about JSON. In upcoming lectures, we are going to start writing JSON for configuring our project. There are going to be plenty of opportunities to get practice. Feel free to experiment with the playground. For convenience, the playground recommends a few examples. You can click on these examples to view different combinations of data. Once you're finished playing with JSON, I'll see you in the next lecture. In this lecture, we're going to initialize Composer in our project. Before we can start installing packages, a configuration file must be present. This file contains basic information on our project, such as the project name, author, and list of dependencies. Initializing Composer is simple. If you haven't already, open the command line and make sure it's pointed to your project. I'll be using Visual Studio Code's terminal, which automatically points to our project. Inside the command line, run the following command: Composer. Since you're new to Composer, it can be confusing as to what's possible. For example, how did I know the availability of the version flag? Aside from reading the documentation, you can just run the command. Running the command alone provides a complete list of features. Firstly, we're given a list of options. I refer to them as flags, but options are another name for flags. As you can see, the version flag or option appears in the list. We are even given a description for more info. We can apply any of these flags to change the behavior of the Composer command. Below the list of options, there's a list of subcommands. We can perform operations from installing packages to diagnosing our project for errors. The subcommand we're interested in is called init. As mentioned in the beginning, we must create a configuration file, which this command does for us. Technically, we could create the configuration file manually. However, to reduce the likelihood of typos and errors, I think it's a better idea to let Composer create the file. Inside the command line, run the following command: Composer init --help. We're able to view a complete list of options for the Composer command, but what about its subcommands? Before using any new command, I always recommend viewing the list of options. This practice will give you an idea of what's possible. Every subcommand supports the help option. By adding this option to the command, a list of options specific to the command becomes available. Keep in mind, these options are completely optional. We don't have to use every one of them. Based on this information, I don't think we need to use any options. Let's try running the composer init command. After a few moments, Composer will ask us a few questions about our project. The configuration file will be populated with the information provided by this questionnaire. Firstly, we're asked for our project name. The format for the project name is the vendor, followed by the name of our actual project. If we don't provide a value, Composer will use the value inside the square brackets. In my case, it was able to detect my name and the project name based on the folder. If it doesn't pick up your name, that's perfectly fine. You can always input the name manually. The vendor portion of the name refers to your name or your online name that you use for development. I'm fine with the default value, so I'll proceed to the next option. Up next, we can provide a description of our project. I'm going to use the following description: a PHP application for tracking expenses. Afterward, we may be asked for the author. By default, Composer may try to use your GitHub account. If you don't have Git installed on your machine, you may not be given this option. That's perfectly fine. You can just type your name. It doesn't make that much of a difference. Subsequently, we can select a minimum stable version. For our project, we're not going to need to fill out this option. Let's leave it blank. Next, we must specify the type of project we're creating. Composer is not exclusive to personal projects. We can use Composer to help us create packages to share on Packagist with other developers. Since this is a personal project, let's set this option to Project. If you're publishing this project, you should consider setting up a license. Different licenses are available, but that's beyond the scope of this lecture. We're going to leave this option blank. Once we've got the basic questions out of the way, we're going to be asked if we'd like to add dependencies. Dependencies can be specified ahead of time. For this project, we're going to install dependencies later. Let's set the option to No. Composer is going to ask us if we'd like to select development dependencies. That sounds strange, right? Weren't we just asked the same question a moment ago? In Composer, there are two types of dependencies. After you've finished working on a project, you will most likely deploy the project to a production server. These are considered your primary or production dependencies. However, not all dependencies need to be shipped with an app. Some dependencies may be for development purposes. There are packages available to help you test and debug your application. They're not meant to appear in the final product. In that case, you can list them under the Development Dependencies section of your configuration to prevent that from happening. Similar to before, we're going to select No. Don't worry, we'll install dependencies in an upcoming lecture. The last thing Composer will ask us is if we'd like to set up auto-loading. This feature is incredibly helpful and commonly used in applications. However, we're going to select No. In a future lecture, we're going to manually enable this feature and discuss how it works. So, don't worry, we'll definitely get an opportunity to explore this feature. After you've made your selections, we'll be given an overview of our configuration. As you can see, the configuration is just a JSON file. Let's generate this file. In a few moments, a new file appears in our project called composer.json. We've got a regular JSON file. Composer uses this file to learn about the dependencies for our project. Looking closely, the information from the questionnaire has been used to set the properties. Most of this information should be self-explanatory. There's one property mysterious to us called requires. The requires property is an object of dependencies for our project. Since we don't have any dependencies, the object will be empty. That's to be expected. In the resource section of this lecture, I provide a link to the composer.json schema documentation. If you're curious about what properties can be added to this file, you can check out this page. Composer does a good job of documenting its features. In the next lecture, let's include Composer in our project. In this lecture, we're going to generate the files for auto-loading our classes. Aside from the composer.json file, nothing else has been generated in our project. We must instruct Composer to generate files for auto-loading our classes. First, we must configure auto-loading. By default, Composer doesn't assume which classes can be auto-loaded. In your editor, open the composer.json file. At the bottom of the object, add a property called auto-loading. The value for this property is an object. Inside this object, add another property called PSR4. PSR4 is not the only standard available for auto-loading files. The PHP community has other standards available for auto-loading, which are supported by Composer. Therefore, we must specify the standard we'd like to use. The value of this property is another object. Inside this object, we must provide a list of namespaces in our project as properties. Let's add the framework namespace with 2 / characters. The property name must be our namespace. We're adding 2 / characters to prevent escaping in our string. The value must be the directory where our classes can be found. In this case, the path is the following: source/framework. Here's what will happen. Composer searches through our project. If it finds that we're using the framework namespace, it'll auto-load those classes on our behalf. While we're here, let's include a namespace called app. The directory will be source/app. At the moment, we don't have a single class with this namespace. In the future, this namespace will be utilized for our application. After modifying the composer.json file, we are required to manually update Composer's list of auto-loaded classes. Luckily, this process is easy. Switch over to the command line. In the command line, run the following command: composer dump autoload. This command forces Composer to generate a new set of files. If you look at the project folders, there's a new folder called vendor. Composer creates this directory for storing files generated by it. In the file tree, open the vendor/composer/autoloader psr4.php file. This file is generated by Composer. If you look through the file, our namespaces have been included. With this information, Composer can auto-load files under these namespaces. This step is very important. If you decide to add a new namespace, you must always generate these files. Otherwise, our changes won't take effect. Let's try testing this behavior. In the next lecture, we're going to load these files into our project. In this lecture, we're going to load the files generated by Composer in our project. We're going to perform this task from the Bootstrap file. Keep in mind, our dependencies are written in PHP. Therefore, we can load them like we would any other PHP file, which is by using the include or require keywords. Replace the include statement with a require statement. The path will be the following: require __dir__ dot/vendor/autoload.php. We're switching to the require statement because our project won't work without Composer. Therefore, we should throw an error when a file from Composer can't be included. The file we're loading is called autoload.php. Why not the autoload PSR4 file? The PSR4 file contains a list of namespaces, but it doesn't contain the actual logic for autoloading files. This logic can be found in the autoload.php file. It'll handle including the PSR4 file during initialization. Let's try testing our app by refreshing the home page. Our application continues to work. Technically, the Bootstrap file is not loading the application file. Despite that, Composer was able to find the file since we're referencing the class from its namespace. Now that we're auto-loading files, we don't have to worry about requiring files in our project. Composer can handle this step for us. I know it doesn't seem like a big deal. All we did was replace one line of code with another line of code. However, we no longer need to include files from our application or framework. They'll automatically be included in our project, which is going to help our code base become more readable. In addition, we're also following the PSR4 standard, which is commonly used for auto-loading files. We're finished configuring our project. I know we've discussed a lot of theory and written very little code. Establishing a foundation for our project is going to go a long way. Before moving on to the next section, there's one final set of topics I want to touch upon. In the next lecture, let's start talking about Git. In this lecture, I think it's time that we start talking about version control. The topics discussed in upcoming sections are going to become difficult. You're inevitably going to run into problems. If that's the case, you can ask for help in the Q&A section. In some cases, I may ask you to share your code base. The best way to do that is through GitHub. That begs the question, what is GitHub? Let's talk about it. To begin this discussion, we need to talk about Git. Over time, your project is going to evolve drastically. The current code base for a project may look different from the code base a year ago. In some cases, you may want to revert a project's code base to an earlier copy. Manually reverting your changes can be a pain. Tracking the history of your code base is an essential step for maintaining a project. Another problem that may arise is inconsistent collaboration. If you're on a team, there will be multiple copies of a code base. What if someone on your team is working on an older version? What if you and your teammates perform different changes to an application? Collaboration is a key component of any successful team. Git solves these problems. It is a tool that can record changes to your project over time. These changes are stored in a database called a repository. By recording your project's changes, you will know what changed, when it changed, and why it changed. Best of all, Git can easily revert your project to older versions. What about collaboration? Git is capable of helping you and your team sync your projects together. This type of software is referred to as version control. There are various tools that can perform this type of action. However, Git is considered the best tool for a few reasons. It's open source, free, and easy to use. Over 90% of developers around the world prefer Git. This brings us to GitHub. You have the option of using Git without additional help. However, many developers prefer to work with a company that can host their projects online. On top of hosting projects, most companies offer additional tools for collaboration. The most popular platforms for hosting projects managed by Git are GitHub, GitLab, and Bitbucket. In my opinion, GitHub is considered the best platform. You're more than welcome to explore your options. With that being said, I'm going to show you how to use GitHub to host your projects. In the next lecture, let's learn how to upload our code base to GitHub. In this lecture, we're going to start using GitHub to host our application's codebase. Typically, most tutorials will show you how to use Git with the command line. However, that won't be necessary. GitHub offers a desktop application for managing projects. You can skip the command line. In the resource section of this lecture, I provide a link to this tool. I want you to download and install it. While you're downloading the desktop application, create an account on GitHub. You're going to need an account. After you've sorted everything, let's learn how to upload our project to GitHub. By uploading it to GitHub, you can share your code with me when I ask for it. First, open your project in the File Explorer. Before we upload our project to GitHub, we must delete the vendor folder. The vendor directory is necessary for our project. However, it's a directory that can be generated by Composer. If files can be generated, it's considered good practice to exclude them from a repository. If another developer downloads our project, they'll be responsible for generating the vendor directory. The reason is simple. The vendor directory can easily become bloated with code. Uploading and downloading code would take too long. For this reason, developers omit them from a repository. After deleting the vendor folder, let's open the desktop application. You should have been asked to connect your account to GitHub. If not, that's fine. You can connect your account by going to File Options. The tool provides an option for connecting your account. I'm going to connect my account. After connecting your accounts, we can begin uploading our project. As I stated before, Git stores copies of your project in a database called a repository. Therefore, we must create a new repository. We can create a new repository by dragging the PHP folder into GitHub Desktop like so. A pop-up appears asking us to create a new repository from this folder. Let's select this option. After selecting this option, GitHub prompts us for some basic information on our project. Let's go through the options one by one. You can call your project whatever you want. However, I highly recommend keeping the name short and concise. Let's set the name to PHP. Next, we need to provide a short description. I'll set the description to the following: a PHP application for tracking expenses. Afterward, we need to point to the project directory. This is the most important step. What should you upload? You should always point to your project's root directory. I'm going to point this repository to our project. The following steps are optional. However, let's go through them. The next option will ask if you would like to create a README file. A README file is useful for creating a document that describes your project to other developers. Let's allow GitHub to create this file. The Git ignore option is another file that can be created for projects managed by Git. In some cases, you may not want to share files with your peers or the community. The Git ignore file lists files and directories that shouldn't be shared with others. Unfortunately, there isn't an option for PHP projects. For this reason, we're going to select the Composer option. The Composer option is available for projects that are using Composer to manage their dependencies. It's the closest option available for PHP projects. Lastly, we can set a license. I'm going to select the MIT option, which offers the most freedom to developers. We can click Create to create the repository. This process may take a few moments. Once your repository is created, the hard part is over. At the moment, your project is only available to you. It has not been uploaded. You can upload your project by clicking the Publish button at the top. Let's do that. A pop-up will ask you for some final details. We're going to be uploading our project to github.com, not the enterprise version. The most important setting is the private checkbox. This option should be turned off. Otherwise, you will not be able to share your project with me for help. After making those changes, click Publish. Our project is finally available for sharing. The application should provide you with the option of viewing your project in the browser. By clicking this option, a new tab will open. The link in the address bar should be shared with me whenever I ask for it. Perfect! You have a repository dedicated to your project. If you make updates, you can publish those changes to the same repository. You've mastered the basics of Git. There's one more thing I want to show you. In some cases, it may not be necessary to upload your entire project. You may only need to share a single file. If that's the case, you can create something called a gist. At the top right corner, click on the plus icon. There's going to be an option called New Gist. A gist is a feature for sharing single files on GitHub. It's unnecessary to create an entire repository for a small snippet of code. On this page, all you have to do is provide a name, paste in your code, and click Create. Super simple. If I ask you to create a gist, this is how you would do it. Overall, that's Git and GitHub in a nutshell. There's so much more that these tools can offer. In the resource section of this lecture, I provide a link to a YouTube video by Free Code Camp. They have a rundown of all the features you'd like to know about these tools. I highly recommend checking it out if you want more information. For now, the bare basics will work. In the next lecture, let's explore the modifications made to our project by Git. In this lecture, we're going to look at the files generated by Git in our project. By using the GitHub desktop application, two files were created in our project. The first file is called Git Attributes. During the development of your project, you're going to create and update files. As you do so, Git saves your changes to the repository. This file allows us to modify the settings for specific files. We can instruct Git to save files differently from others. Inside this file, there's a comment, which is indicated by the hash symbol. By default, the desktop application has configured this file to normalize new lines. I know it might not seem like a big deal, but line breaks can be saved differently. Whenever you add a new line to a file, editors add a hidden character to indicate a line break. There are different characters available for representing a line break. The most popular are LF and CRLF. But why is this important? Does it matter what line break we choose? In some cases, yes. Not all characters are supported in every operating system. Currently, I'm using Windows. If I switch to Mac or Linux, it's possible my code may not have the same formatting as it does in Windows. To ensure consistency, we can enforce line breaks to be a specific character. In this example, Git will force all line breaks to use LF. LF is supported by most editors. In the resource section of this lecture, I provide a link to the documentation page for Git Attributes. We're not going to be modifying this file for our project. The default configuration is more than suitable. Let's move on to the next file. Open the git ignore file. Saving files to a repository can be a dangerous action. Once you save a file, the contents of the file are accessible to anyone with access to the repository. If you're saving sensitive information, that information would be exposed. You can instruct Git to ignore specific files. A list of files and directories can be added to this file. Since we're using Composer, the vendor directory is ignored. If you think about it, we don't need to include our dependencies with our project. They're already available from another server. As long as we're able to download them, we can omit them from our project. Please make sure the vendor folder does not get committed to your project. If you share your project with me that includes this folder, I will not be able to download your project and help you. As long as the vendor directory is included in the git ignore file, it shouldn't be present. This will allow us to download and upload changes to our project faster. Currently, we deleted the vendor folder. Let's generate the autoload files again by switching to the command line. Run the following command, composer dump autoload. After doing so, the vendor folder is available again. Let me show you another feature of Git. By default, Git doesn't automatically save changes to your project. You must manually perform this process. For example, let's head back to the git ignore file. I'm going to add an imaginary file to this list called imaginary-file.txt. Afterward, I'll open the GitHub desktop application. We need to commit our changes. A commit can be thought of as a save point. Git wants to know if the current updates to our project are safe to add to the repository. On the left side, you will be provided a list of files that have been updated. You can click on any of them to view the file. On the right side, GitHub highlights the changes. As you can see, Git was able to detect the changes to the ignore file. At the same time, the vendor folder has been completely ignored, even though we added it to our project again. Our changes must be committed. Let's try committing our files. At the bottom right corner, we must provide a summary of our changes. I'm going to set the summary field to update.git ignore file. The description will be left empty. Let's commit our changes. After committing those changes, they'll be saved on our system. However, they won't be saved on GitHub. We must sync our repository with the repository uploaded to GitHub. Luckily, we can do that with the press of a button. This step is critical. Oftentimes, students forget to publish their changes to GitHub. If you forget to publish your changes, I won't be able to see the latest copy of your codebase. Alright, There's one more thing I want to discuss before moving on to the next section. In the resource section of this lecture, I provide a link to the completed code for the project we're building. If you ever want to see what the final product will look like, you can check out this repo. There's a button for viewing branches. For your convenience, I've added the completed code as a branch for each section. The main branch contains the completed code for the entire project. If you want the completed code for a specific section, you can click on any of these other branches for those sections. That does it for now. This information will be more than sufficient going forward. In the next section, let's start working on adding a template to our project.